All right, welcome back. We are COMP397, that's web game programming, in the winter 2021 semester at Centennial, and it's week 6, part 1 of our broadcast. And today we're talking about a very interesting topic, or some topics. One of them is animation, another one is particle systems, and we're going to see if we can get to post-processing today. So that's what I'd like to do, and post-processing just color grading. Let's take a look at a couple of things that's happened. So last week we did a bonus lab. It was kind of a shortened week because of Family Day. So we kind of did a little bit. I excuse me. I added an extra section on Git and GitHub and Unity Colab. Wasn't really something that I planned to do, but I think the great thing about this was you got a chance to see how you can use Git and GitHub and collaborate with Unity, which is pretty cool. We also created a death plane and something called a spawn point that we added for the player, just in case they fall off, kind of the world that they're on and land on, well, they keep falling unless you land on something to respawn the player somewhere else. So we talked about that last week. As well as we didn't do this part, enhancing your mini map with Cinemachine. We didn't kind of get to that, but we did talk about a little bit about Unity UI. We built some simple assets and we developed a very simple health system with health bars. So 2 types of health bars we created last week. One of them was a screen space health bar. The other one was a world space health bar. And then you can attach those things to any one of either the player or the enemies or an inanimate object, and then just associate the health through a script to kind of show what the health of the object is. So that's what we did last week. This week, we're talking about Unity's animation system. We're going to use Mixamo, which is something of an online character creator. I'm going to get you to start with that soon. We'll talk with that. And then the other thing that we're going to talk about is a bit of particle effects. We'll see if we can make a simple dust trail. And then if we have time, we'll get into post-processing color grading. This seems like a lot or very simple, but actually there's a lot in here to make everything work. And there's a bunch of scripting to do as well. So that is this week's schedule. So in terms of what's due? This week we actually have assignment 1, part 3 due on Sunday. And I kind of released that and talked about what was required for assignment 1, part 3. We also have lab 6. This time it's going to be required. It's due on Saturday. And I'm working on right now, going through all the marks. There's quite a few of them, obviously. I'm releasing your group marks. It's taking time, but I will get them to you as soon as I can. Next week, we're going to be talking about sounds and impulse sounds, different kind of sounds, how to make sound effects, how to use soundtracks, what are spatial sounds, what are dynamic sounds, and how to create a sound manager if we need one. So that is next week. And where we're sitting right now is week 6, kind of at the bottom of our first half of semester. We're just one more week away from, wait a minute, is that true? Hold on a second here. I think I have. What we did was, that's next Sunday, not this Sunday. Let me just make sure this is correct. So it shouldn't be this Sunday. It should be next Sunday. You still have an extra week for this. And I'm just going to check eCentennial to make sure that that is true, because I wouldn't want me to tell you. Yeah, it is. So it's March 7th. So March 7th falls on not this Sunday, which is the 28th, but the following Sunday, March 7th. Oof, okay. I was worried a little bit too. I was like, wow, that's a lot for them to do in 2 weeks. So yeah, there's quite a few things we're going to cover in terms of all the things that are required. So this is due next Sunday. So that's week 7. Okay, that's assignment 3. I just want to keep your eye on the ball there. And that's why when I looked at it here, I was like, wait, that doesn't seem right. So next week is all around sound, right? That's what we're doing. And then after that, in the second half, this is where we get interesting and start doing things with mobile. So that's where we take our game that one you kind of developed for the first half and spin it into a mobile game. So you're going to have potentially 2 games, one for the web and the other one for mobile. And that's what this course is all about. Okay, so before we get going, I want to talk about the 2 topics briefly that we're going to discuss. One of them is the animation system. And what is it? It's called Mechanim. Actually, that's what the old name was that I've been using for a long time. And basically what it uses is a bunch of little piece parts to produce a really cool animation effect in 2D and 3D. But before we get there, I want to kick off our project. So let's go back to Centennial. And if we look at eCentennial, underneath there, under Content, for today, we have under week 6, we have a GitHub repos area where we have Lab 6 Starter, which is just Lab 5B or Lab 5 as a start point. So if I go there, you're going to get this, which is Lesson 5A. I'm going to download this like I showed you guys last time. So I'm going to download the zip file here. And I'm going to start fresh, just like you would start if you were starting off from this. I'm just going to also pull up my desktop for a second where I have everything, and I'll pull everything up on screen in 1 sec. So let's take a look. All right, here we are. This is our a little workspace. I'm just going to drag and drop that in. That's the thing I just downloaded, and I'm just going to unzip it. So this is the way you would do it. You'd unzip it here, and then delete this one. I don't care about that anymore. I want to rename this to 6A. So this is just this part renamed. Oops, not 56A, but 6A. There we go. And notice 6A is, even with everything else we did last week, and we added advanced stuff or whatever, it's pretty small, right? So, I mean, relatively. So if I kind of hover over, it says 23.8 megs. We went up a little bit compared to the previous week, which was, 23.7 megs. It's really small. This is just with everything from last week. If I remove the library, right, as an example, and remember I talked about things to submit. So I can remove the Git repository, the library for sure, any builds. If I just remove those 2 things, just those 2, and maybe the VS folder, I mean, that's pretty much pretty simple. If I really remove those things from last week's project, right, as an example, and I just kind of hover over it, it'll tell me that it's about 27.4. The one I downloaded is 23.8, which is even cleaner than the one that's online, or the one that I did locally. So this is where I'm starting from. So again, what I'm doing is I'm pulling up my command prompt today. I'm going to use my command prompt as opposed to using Gitkraken, but you can do any way. You can use any method you like to kind of put this up on GitHub. So I'm going to go CD space and then drag and drop lesson 6A in there, and then git init, git add dot, git commit -m. One day when it feels like showing me that. Initial commit, initial commie, yay! Initial commie. All right, it wasn't intentional, and then that's cool. So that's pretty cool in terms of what we've done. We're ready to go. Let's pull up everything on Unity Hub. So there's Unity Hub. I'm going to click Add, and I'm going to point to Lesson 6A and click Select Folder. And then we're ready to go with Unity Lab 6, which is what we're doing today. Is it Lab 6 today? It is Lab 6. So that's what we're doing. We're doing this part. I'm just going to step through each part of these things and go through it. So we have some pretty boring characters right now, right? Really, really boring, enemies. And I think what I'd like to do is make them a little bit more interesting. Right now, they're like literally just capsules. And that's just not really fair or not really that interesting. So I'm just going to make it so that the characters are a little bit more interesting than what we see. And I'm going to add in a couple of states. We're going to talk about all those things. And I'm going to start with the character creator online. For us, that's probably going to be enough, called Mixamo. But I'm also going to talk about other ways of creating characters if you're interested. And you can also download stuff from Unity's asset store for your project. That's totally in line, no problem. Okay, so here we go. I'm going to back to I'm going to go back here to scenes and double click on main. And it says import TMP essentials because you know what? I'm using Text Mesh Pro, so I need to import that again in order for me to have issues. And you'll have to do the same thing now to start going. One thing we also have in Collaborate is I have this project in Collaborate. And under Services, you can see under Collaborate, it's on, right? It's on. For today, let's turn this off. So we're going to turn this off because I don't want you guys to do Collaborate today. Okay, so that's just, again, I went to Collaborate under Services. And the way to get Services, again, is if you go to Windows, and then you go to General, if I'm not wrong, and Services right here. That's where you get the Services window, which is this window right here. And then to turn off Collaborate, just go here and then just turn it off. Yeah, that's how you have to do. So Collaborate again, you can, hopefully you did that and you checked it out and it was pretty fun for you, but we're not going to use it this week. Okay. All right, so we have some pretty boring characters. This is the project we have. Right now, we can also see the characters in all their glory. Let's see what we had from last week if I run this project. So here's something. I have the health bars. This is pretty cool, right? And if I jump on here, you can see the health bars. That's what I have so far. If I press the tab key, my little, kind of menu comes down. And that's what we did. If I press the M key, I get my little mini map. So I'm starting to get some functionality in here as well. We're going to build on the things we did last week. Okay, so that's kind of very simple, a very little level, not much bigger. And you know what? I see these things here, these little markers. Again, you can go to layers and then just turn it off. If you don't want to see them, I don't want to see them. And, there's no need for us to see them. Okay, so cool. So I want to make some interesting characters here. Instead of having these boring enemies, let's switch this out and make it more interesting. Okay, so for now, let's get rid of the enemies. So bye-bye enemies. See you later. We have our enemy marker, but I want to make it more interesting. Let's go online and to a tool that I'm going to recommend to you and as well as introduce, if you haven't seen it already. It's called Mixamo. So Mixamo, let's go there. I'm going to bring up Mixamo, and I'm going to put this link on eCentennial. So under eCentennial, I'm going to go to course lecture, and under course lecture, I'm going to add a brand new link. So this is going to be, again, new link. We'll call this Mixamo. And then what I want is this link right here for you guys to go there, open an external resource. And then, okay, now to use Mixamo, and we're going to talk about this, before we start, please sign up. It's a free sign up with Adobe. I know that some people don't like to do this kind of stuff, but it's totally simple to sign up. It's not, the tool is free to use. It's not something that requires you to pay anything or anything like that. It's a really great little creator. Highly recommend. Let's go back to Mixamo. But if you already have an Adobe account, or you've already signed up for Adobe for free, there's a lot of little things you can do. One thing you can also do is use the color wheel, color.adobe.com, where you create the color wheel for your color swatches for mobile, and we'll talk about that for the next assignment. So this is something that you can do. You can kind of create color swatches, blah blah. That's also required to sign in to save your stuff. But you can also do something with Mixamo. So Mixamo is an online character creator tool. So notice that I can go to, there's two links here, characters and animations, but I'm going to log in. So this way it can remember my choices. And here it is. So I'm staying logged in. Awesome. So what it looks like is like this. I'm going to go to characters first. So click on characters, and hopefully you're there with me. Okay, so checking for the people online, check mark if you're with me, X if you're not. Again, I'm going to Mixamo. I want to wait for you guys because it's an important piece to go through. And we're going to pick an enemy that's going to make sense for us. All right, so Eric says yes. Thank you, Eric. Anyone else with me that's physically here? How about our fine folks on YouTube? Anyone with me on YouTube? Maybe some of you people on YouTube can also respond. All right, so we can choose any one of these characters. So what this does, we need, in order for us to do animation, we got to talk a couple of things, okay? So one of the tools we can use is this Mixamo thing, okay? And what it does is it can provide a character mesh, a three-dimensional character, basically a placeholder character for you to use free for your games and other projects, right? And what you want to do is put the character in something called T-pose. Notice that this is T-pose, right? There's two main poses actually, and let's take a look at the two. If I was going to say T-pose and A-pose, those are the two poses that you're going to see a lot, right? That's out there. And depending on the model that you're going to get, these are the kind of poses you can get. There's A-pose. I'm just randomly going to a site here. So there's T-pose and there's A-pose. And the reason why we want to start a model in T-pose is what we want to do is we want to modify the model, and in order for it to do what we want to do. Now we're going very high level here, and I'm not going to go into a lot of detail, but one thing to note is that all models have something called a rig that is kind of behind the model. So we have a humanoid model as an example, and then some artist has created it for you. Now, making a model here in class for us is out of scope. And if you've taken COMP397, if you're a gaming student, then you may have taken organic modeling, where you actually learn how to create the bones and the rig for your character. Awesome. And so what it is you have a mesh, and then behind the mesh or inside the mesh, you have these bones. And in the bones of the mesh, I'm just going to randomly pick this thing for Blender artists. This is just a nice little image for us to use. If you look at the bones inside of the model, then you can see that for the model, every part of the model corresponds to one or more series of bones. And the way it works is it deforms the model. When the bones move, they're linked to the current positions of the mesh that are nearest to them. I'm really high leveling it here, and I mean that in terms of, I'm not talking about paint weights or anything like that right now. For those people who know what I'm talking about, I'm just saying that the bones are inside the model, and when the bones move, the model deforms to kind of match the bones position. At the very at the very minimum, that's what it does. So that's how it works on the back end. It's just very, very simple like that. And what we want to do is these bones, and again, they kind of look more like this inside of Blender. So they're literally inside of the character model. You just can't see them. A lot of times they're invisible. But we have a model as an example, and the bones are inside the model. And you can see that all the models either start in A pose, right, or in T pose, something that looks like this. Sometimes what character modelers would do, one of the processes is to get a character reference. So someone draws it out for you, and usually they do a side pose, they do something in T pose, and they might also take the back of the model. And then what your job is to actually try and model out the characters as best as possible. The way we do that in real life is we use some kind of voxel painting program like ZBrush. So ZBrush is an example of a voxel painting program. It's a little different than Blender, in that Blender uses basically quads, if you will, or triangles. And this doesn't really use triangles. It uses voxels, which are very, very much smaller. Also, one thing to note about models that are created in something like ZBrush, and this is just one tool. Another tool would be something like 3D Coat, which is something that's up and coming. I really like it a lot. 3D Coat is something that I've learned how to use a little bit as well. It's a lot cheaper than ZBrush. All right, so 3D Coat is very similar in terms of what ZBrush can do. So let's take a look at some gallery for what 3D Coat can do. So again, 3D character modeling, organic modeling is mostly what it's for. Okay, it can do hard surface modeling like Blender as well. Not really geared for that though. It's really geared for this. And it's a combination of organic modeling that you can do. So in other words, if you think about like clay sculpting is more like what's happening here. And what you want to do is push around the object to model it as much as possible. So what's happening here is you are going to modify the structure to make it look like an organic model. And then what you want to do, this is very, very high poly, so very, very high density of polygons. And what you want to do is you want to retopologize it. Now, usually the process goes like this. You make a very high poly model. Then you use something like, and it doesn't matter whether you use 3D Coat or some other thing, even Blender, by the way. I'm just going to bring up Blender here for a second. Blender also has a tool that you can use for sculpting, and that's really what you're doing with 3D models. And so does, I also have to say, so does Adobe's Mud Brush, or, there's a, another Adobe. I'm sorry, I'm thinking about Autodesk. Right, Autodesk has its own, program as well. Every kind of company has something. So here's an example. I have a cube. In order for me to do any kind of modification on this, and I'm not expecting you to do anything right now. Just watch, guys. I have to make this a very high poly model. So normally what we would do is we would subdivide it a lot. So something like, let's say I went in here and I subdivided a bunch of times, right, to give myself more geometry to play with. And then I do it again, right? So let's just do it a lot more. So here's more geometry, and let's just really get thick there. Now you can see that there's a lot of geometry, and you're like, wait, that's a lot, Tom. Yep, but that's what you need in order for you to have control of what you want to do. So then what you do is you take this high geometry model, right, as an example, into the sculpting side of the program. And then what you do is there's different brushes. And what you can do is you can sculpt the model by adding, modifying or deforming the geometry, right? Now, this is very high poly. And what you want to do is from this, you want to, you want to take it down and do different things. There's different tools that allow you to do things like, some detail, if I want to do line details and so on with Blender. But Blender's getting better and better. But at the end of the day, what's happening with Blender is that it's kind of a general purpose tool for character modeling. That's what Blender's like. But there's some way better tools in this. As you can see, I've got like more control. There's different tools that allow you to do different kinds of buildup, whatever. And that's what kind of the organic modeling is. So you take a model like this as an example. Let me just go back and do this one. And let's say I'm making a character, like some kind of tentacled character, right? And you start off and you start really, kind of fleshing out what it's going to look like. You block it out, and then you add more and more detail. And then what you want to do, this is very, very high poly. You want to go from a high level of detail to a much lower level of detail by retopologizing it. Now, Blender has tools kind of here to make this lump of whatever this is, to make it nicer and to retopologize it. And basically what you want to do is overlay a low poly model on top of a high poly model to create that kind of nice effect. But tools like ZBrush and 3D Coat do this a lot nicer. Then what you do is in the workflow, what you want to do is you want to take this into something like Topogun. And this is a professional workflow. So again, Topogun, expensive. But what you do is you take a very high poly model, and like you can see, there's a lot of detail here. But what you do is you bring it into a program to retopologize it and make it lower, kind of lower the number of polygons, still keeping the general shape of the model that you get, as an example. But in order for you to get this kind of detail, you need to have, there's kind of a process. You can feed it through a process. Topogun makes it very easy for you to topologize, and it creates low poly models, low polygonal models from high poly models. That's what it does. Okay, and there's some examples here of things that you can do. That's what they do. They're retopologizing. And they also bake maps, which is really cool. So what you want to do, you want to make normal maps and other kinds of height maps to kind of modify the geometry, or modify the way the light hits a model to make it look like, again, it's very high poly, but meanwhile, it's very low poly. So why do we want low poly models? Why do we want to retopologize like this with another piece of code or another program? Because it's computationally expensive to have very high quality models in a game, especially if you have hundreds of enemies on the screen at the same time. You want to reduce the number of polygons that are being shown, so that way you have a little bit of control over the, kind of your memory as well as everything else. So you can see the process. This is kind of a really nice way where they kind of reduce the number of subdivisions lower and lower until you have something that is still quite nice in terms of the way it works. And they also have this topo gun also has a built-in morpher to check and see if how your model will be morphed or changed, as an example, relative to the original topology of the model. So kind of really cool. And yes, you can do this, but 3D Coat, as an example, also does retopologizing. It's built in, and so does Blender. So there's some processes that you can use to do it without using separate programs. And that's why I think 3D Coat is a great all-round kind of program that does everything in one. All right, so that's the workflow that we're talking about. But now this is beyond the scope of this course. For us to do a 3D model and do that, it would eat up a lot of time, and it's something for a whole course, not just one module. And it would be really doing you no justice to making this happen. So that's why we're skipping. We're not doing any of this stuff. We're skipping because we're programmers from, hey, this is the model, this is how we make it. We're actually going back all the way to Mixamo again. So now we have a model, and then you can see that there are quite a few of them. You can also, by the way, after this, I'll show you how to, take an existing model and upload it to Mixamo as well. So there's two options you can use here with Mixamo. All right, so let's suppose we want a model, we want an enemy to chase our player. Now I've looked at this one as an enemy. Let's look at some other enemies here that we want to chase our player. So again, we can make it so that is the ninja or something funny like the mousy dude or whatever else you want. Choose something that makes sense for you right now. You choose a model. It doesn't really matter which one, because we're going to do it together. So let's suppose I wanted to use something a little less scary than this guy. And let's say I want to use this guy, Crypto. So Chadwick says, is it okay to take a model from ripping sites? Well, I don't care where you get your models, to be honest. This is for educational purposes. As long as you credit where you're getting them from, it doesn't matter to me. Okay, so this is a dude. His name is Crypto, it looks like, and you can see this is the 3D model. He starts off in T-pose. By the way, if he doesn't, you can always put him in T-pose, and I'll show you how to do that in a second. All right, so this is the model. I'm using Crypto. If you want to search here in Mixamo, if you're up, you can just search for Crypto if you want to do what I'm going to do. And I'm also going to put this model, a reference model, up on eCentennial as well, and I'll show you what to do. There's going to be several animations we're going to get from Crypto. All right, as an example, but this is where we're going to start, Crypto. Cool, cool. All right, let's get going. So that's the first thing. So get the model. Now, we want to download this as T-pose. So let's suppose you don't have T-pose right now. There's two tabs here. One tab is character. So I've just chosen a character. And the next tab is animations. Now, these animations, my friends, are motion captured. So let's talk about motion capture for a second. Motion capture. Motion capture is an art. And what it is it actually, what people do is they get in these mocap suits. That's what they are, mocap suits. And they have these little dots. These little dots are reference dots. And what they do is they map to each joint of a person's body, right? This is how they work. And these little white dots are different. Normally they're on some kind of in a room, a mocap room. By the way, I've been to the one that Ubisoft Toronto has, which is actually, it looks like a small gymnasium. That's how big it is. And it has, I think it has over 120 cameras. And what they do is a mocap room has a bunch of cameras in place. So you might see a bunch of little cameras here all over the place. And what the cameras do is they actually film, or they record, if you will, the actors that are on the stage. And so you might have professional actors. Here's an example of a professional actor that's used for to do motion capture for Avatar, as an example. And you even have motion capture reference points on a person's face. So you can actually capture their face. So what motion capture does is it captures realistic animation so that when a person opens their mouth, it changes what the model would look like. It'll deform the model. But in order for you to deform the model, you must have a set of bones, or it has to be, like we said before, rigged. Something that's already rigged is what's happening here. And then, so you have a mocap suit plus a face rig, usually something that looks like this. Here's an example of a face rig, right? Andy Serkis here. So you can see his face is being mapped on to the mesh in film, and they use it for video games as well. Here's Gollum, right? Here we go for Gollum and stuff like that, Lord of the Rings. And there's a bunch of stuff like this happening everywhere. And one day, we're going to be able to do mocap or motion capture, right? Just by using our device at home. For example, maybe an Oculus Quest device. If you're going to use VR, let's just use if I go to the Oculus Quest 2. One thing that's really cool about the new VR device, Oculus Quest, and you might think I'm, kind of going off topic here, but actually I'm not. What's happening is there's little cameras. There's inside-out tracking on the Oculus Quest 2. And not just the Oculus Quest 2, but also the Vive Cosmos, right? As well as other VR headsets. So can you imagine when it allows you to track your body's position in real time. And if you can do that and you can map your body based on machine learning algorithms that basically track where your body is, one day what's going to happen is we're going to be able to do real-time motion capture so that you have VR presence, maybe in another iteration of this thing, maybe the Quest 3 or something further down the line, or some other thing that Apple's coming out with in the near future. Who knows? But it's coming. And why? Because there is one of the things about VR and XR in general, and that means any reality, whether it's augmented reality or virtual reality, is mapping your body, because people get this idea of something called body dysphoria, where they don't really see their body and they feel that it's breaking the illusion. But anyway, so there's some really good kind of reasons for doing motion capture. They do it for animation. For example, some of the things that you see in creatures you might see in the movies, and those kind of things are done by using a lot of motion capture. They do the same tricks that we use for video games are the same tricks we use for movies. So what they've done is they capture data based on people's positions. So you have actors posing and doing things, then we capture the data and we create a data set, right? Or a mocap. We have mocap data is what it is. And what Mixamo has done for us, which is really cool, is they've got some motion capture data that we can apply to a model. So example, someone doing capoeira, which is a martial art. If I click on this one and I apply it to the model, now you can see that the model is deforming and doing capoeira, or a bit of capoeira. All right, so that's what it's doing here. Guys, I know this is very high level, and if we were all gaming students, as an example, and we had done COMP397, this might be a different conversation. For now, we can assume that, right, you understand that this data that's coming here as an example is motion capture. It's somebody, here's an old man, idle. It's somebody that's actually done the acting. We've captured data, and there's quite a bit of it, right? There's tons and tons of motion capture data that they put in here. Some of it is actually also animated. So there's motion capture, and as well as hand-drawn or hand-modified animation in 3D. Sometimes we have to do a little bit of both because, for example, we don't really fly in real life. We don't fly, so making a flight kind of animation is kind of hard to motion capture. So if I go something like flight, if I kind of search for an animation type, right? And if I look at flying, or let's just put it in fly. Okay, there's flying. Here we go, flying. All right, and you can see that we can actually put it in place. So here's what it would look like in place, someone flying. And you can look at it from different angles, right? Someone flying. Again, maybe this person was on a table, as an example, then we're doing the motion capture, and they've got a bit of what looks like an idle flying animation where you can picture them, kind of flying in space. And with a little bit of motion, as an example, so say we zoom out of here, and if I do it, it looks like the person is flying. But the reality is there's no flying. It's just a trick, right? It's just a little bit of an idle animation in there. And there's probably other options here that you might see some jumping, other kinds of things that you might see in terms of the motion capture. This is someone, an actor or an animator, modifying, kind of positions inside of a rig, a bone rig, all right, that's inside of a model to modify or deform the model in order for it to do what it's showing here. So that's what's happening with all these little animations, right? Okay, so why am I showing you this? And because we're going to actually do this kind of stuff. So there's falling, you can see that there's a ton of stuff that you can do to make it interesting, for our model. So what I want is, I don't want these. And if, by the way, if you did what I'm doing here and you had some really weird thing, and if you want to take it back to T-pose, just type in T-pose here in the animations part. And you'll see this character here, which is like a scarecrow. And if I click on them, there's T-pose again. We want to always start with T-pose or some kind of reference pose. And again, the bones are set up in a way that it's going to be just perfect. Okay, let's do a couple things here. So now that I've got this in T-pose, hopefully you got your character, whatever you picked, in T-pose, and you could have picked a character from here as an example. So let's say character here. Any character that you can find here, you can actually kind of preview a lot of the characters in here. There's several pages that you can go through. Pick a character you like to, to use for your example, right? Or if you have a character online that you're using for your game, that's fine too, right? And here I want to T-pose. Now what I want to do is download this guy. All right, so this is the next step. The next step is download. Okay, so the download dialog box that comes up, a little pop-up, it says, what format do we want to get the model in? We can get FBX format, and there's two. There's binary and ASCII, all right? And there's also FBX for Unity. Isn't that wonderful, right? So yeah, we'll try a couple things. I'll try FBX for Unity, and we'll try FBX binary. We'll try a couple of these things to show you what the bones look like, okay? And then we'll get into Unity. Let's try FBX binary for now. Okay, FBX binary, frames per second, we'll choose 60, always, for us. With skin, but skin means you're going to get textures, right? And keyframe reduction, we want none. So this is just FBX binary, 60 frames per second, with skin, keyframe reduction none. I'm going to click download. And I'm just going to name this something that is, kind of crypto. We'll call them crypto. And we'll say binary for the first one. So notice it says T-pose FBX, okay? So we'll say crypto T-pose FBX. Okay, cool. I want to bring this guy, this crypto T-pose.fbx, right? I want to bring him into Blender to see what that looks like. So let's go into Blender. Let's reset this blob to get something a little bit more reasonable, okay? Here's our scene. I want to get rid of the cube in the scene just so we can have more room. And I'm going to keep the lights in the scene right now. I'm going to go to File in Blender, and I'm going to import. And where it says Options, I'm going to import FBX. Now, this is the key here. Okay, when it comes to importing anything into Blender. Before we've saved things out of Blender. But coming into Blender, notice that there's some couple things here. Custom normals, subdivision data. There's a lot of things you can add in. I'm just going to accept everything as is. Okay, I'm going to accept everything as is as I'm bringing it in. And I want to go into the folder I downloaded. I've downloaded my crypto FBX. You can see I've got other ones in here into right here, which is about 15.8 megabytes. Okay, so now this is going to add quite a bit of load to our project. Import FBX. Okay, let's see what that looks like. So when we do that, if you did it properly and if it worked, and it's still doing, give it a second while it's loading. There we are. This is what the model looks like. This is the actual model, okay? And you can see that if I want to see it in high poly, there's the actual model with the texture. All right, this is what it would look like. And you can see that it's pretty good in terms of what it would look like, this guy. But notice that there's a bone right here. There's this bone, right? Well, it's an armature is what it is. An armature is a set of bones, right? And you can see that it is kind of meshed in there, right? With a bunch of vertex group and everything else. And here we have, it says Mixamo org hips. There we go. And this is parented, the model, the armature, and the mesh. This is the mesh. And by the way, I'm going to show you how we can look at things separate, right? So there's modifiers that have been made and everything else. Plus there's a mesh, right? And there's also a default animation. There's nothing that's here right now. But one thing that we can see is if I right-click on the model, right? And if I press tab to go into, or if I go into edit mode, right, you can see that I have a pretty good understanding of what the model looks like. It's kind of low poly. Even though we see a lot of details in the model, right, what we're actually seeing in Blender is a much lower polygonal model than what we're seeing. Notice that there are T-pose, even though our hands are here, this is where the bones are. Look, this is what bones look like, which is kind of interesting. Okay. So, again, so this is kind of what the model looks like, which is kind of interesting. And we can look at different things here. So edit mode, there's sculpt mode, there's weight paint mode, where I want to paint the weights of the model based on the bone, right, as an example. There's lots of different modes here. There's also sculpt mode if I want to go in and sculpt the model. I don't want to do that right now. So that'll take us back to kind of what we did last time, which is not what we want, right? And there's texture paint if I want to modify the model in real time and do everything. But we're all going to go into object mode here. Okay, there's object mode. So on the right, as an example, we can select different parts of the model, right? So notice that, right, if I can make the whole armature disappear, that's the actual armature itself. But the model remains, right? So that's the armature. And as I go in, I could also get rid of the model in here and see what the armature would look like. So this is kind of what the armature looks like, or the bones, right, of the model in Blender. Again, I'm not going to go into details on how this works and how it's positioned, but you can see that the head is detached from the neck a little bit, in that you see the neck bones and a bunch of other bones here, which are kind of cool. So this is an FBX model, and you can see that there's a reference bone at the top of the head in order for me to control it. If I right-click on the model and press Edit, now you can see that the bones there's something that I can modify. And down in the bottom here, there is a bit of an animation loop. And you can see that there's nothing going on. There's no animations. We have a few keyframes, though. And what happens if, as an example, I deselect all and select one of the bones, and then I move the bone, right? So let's bring in our reference model so you can see what happens. Again, you don't have to do this. I'm just showing you what this looks like so you can see what happens. If I kind of move the head around, so I kind of move this around right now, nothing happens because I have to, I'm not editing the entire model, but I can move around the bones, right, as an example. And the idea is that I want to be able to animate my model based on the positions of the bones. Now, there is no animation right here that I can put into because this model is a reference model. It's just a T-pose. Cool, cool. So that's what the model would look like. This is the mesh in front. This is the armature in back. And there's two pieces, mesh and armature. Okay, and what we want to do is bring this into Unity and then modify. We can, like it says in the PowerPoints here, one thing that that the Unity's animation system allows us to do is something called retargeting, where we can actually retarget a humanoid's animation or add an animation to a humanoid model, like so. We can add an animation here. So this is the first step. Okay, so this is the non-Unity FBX binary model. Let's download it one more time, and let's see what happens. I'm just going to go to New. Let's see what the difference is between this model and the one we're going to get made for Unity. So I'm going to go back up to here, back up to Mixamo. I'm going to click Download. And when I click download, instead of clicking just regular FBX binary, which is what Blender takes, we want to go with FBX for Unity. Okay, that's a different layout, if you will, for Unity specifically. Let's download that. Now this one I want to keep, all right? And you're going to notice it's going to be labeled a little differently. It's going to be labeled this, CH45 non-PBR, so non-physical based rendering, so a very simple mesh that we're using here and a very simple texture. And it says T-pose. I want to change this to crypto T-pose. Crypto at T-pose. Okay, the at is important. Okay, I'm going to make this crypto at T-pose and click save. Yay! Okay, it's saved. Let's bring this into Blender one more time, and then we'll go to Unity. So go to File. I'm going to go to Import. I'm going to go to FBX. By the way, BVH is motion capture. That's the kind of data that you get. There's also kind of other kinds of data. A BVH file is the motion capture data, and Blender actually does a lot of the stuff here. But again, we're a little bit out of scope, so I'm not going to move on. I'll move on that one. Let's go with FBX again, and let's scroll down this time. We'll go instead of using the crypto T-pose by itself. Notice they're the same size, 15.8 megabytes. I'm here. I'm going to go to crypto at T-pose FBX. Let's see what the difference is when I get the model. Again, give it a second. Your Blender, if you're going to do that, might take a couple minutes or so to get it. Now, notice what's happened. Undo. Notice what's happened here. The exact same model came in. However, it's changed just slightly. So the configuration is what's modified. Okay, that's the most important piece. And if I kind of color it, you can see that again, I have the same texture applied to the model, right? However, now what I can do is if I was to move any of the parts around, let's say, for example, I want to edit the model, right? So now I'm in pose mode. And if I take the top of the model here and move my head, what we want is for the entire model to be deformed. Right now, again, it's T-pose. So you notice the only thing that changed was that the hands kind of matched now, with the body, right? So again, if I was to hide it, you can see that the hands and the body are matched when I go into edit mode. See? So it actually modifies it in terms of where it's going. This is T-pose, and this is specifically for Blender and Unity. Okay, cool. So that's good. We don't need this anymore. Let's get rid of it. I just wanted to show you what it looks like so you have an understanding of what's happening, what we're getting. Okay. But for Unity, it's much easier than this. Now that we have this model, well, what we can do is we can go to Unity and bring it in. So again, instead of putting it under models, let's make a new folder. We'll make a new folder called Animations. Okay, there's my Animations folder. And under my Animations folder, I want to bring in that model, right? So crypto at T-pose. I'm just going to drag and drop in here from off screen. It just looks like this. I'm just dragging and dropping this one from off screen into Unity like so. And now what we see is crypto on the right. What we also get is a preview of what crypto looks like. Okay, so this is crypto. There's some issues. Okay, there's some issues. What we want to do is remember, once we bring in a model, just like anything else, this first model is the most important one, by the way, because if you don't bring this model in properly, it'll affect every other model. So let's do this. Let's do a couple things. One, I want to generate colliders. And then I also want to generate light map UVs, just like I've done in the past. Okay. I also want to make the model read writable. Okay. That's something that we want to do this time around because we're going to actually modify this model and apply different transformations to it. So that's kind of something we want to do. All right. I'm going to click apply here as the first part. So the first part is let's bring the model, do light map UVs, apply some kind of thing here, and you can see that there is just a empty model right here. Okay, next, rig. It says generic, no avatar. Let us create from this model. Create from this model, all right? And that's the kind of thing I want to do. I want to create an avatar from the model. Click apply, please. There we go. Create from this model. We need an avatar. All right, cool. So we got an avatar. Looks pretty simple. We don't, but the model looks pretty bland, right? Animations, there's no animations right now. It's in T-pose, so if I was to run it, it doesn't do anything. Like literally just sits in T-pose. And we're going to talk about animations in a second. And then we're going to get to materials. Okay, so I want to do a couple things. I want to extract materials, and I also want to extract textures. Now, hopefully, it'll have both materials and textures built in. And if you notice here, we have materials. Here's my material, and hopefully we'll have the texture as well. Let's see what happens. Maybe we will, maybe we won't. All right, and we have this little avatar that was created. That's the little avatar symbol. And we have this little avatar. So this little symbol here, by the way, there's a couple of different symbols. Notice that there is this part, all right, which is the model symbol. There's also this part that looks like it's moving. This little movement symbol right here, this is called a clip, a video clip or an animation clip. And then there's this little symbol here. This little symbol, I just blew it up so you can see it big. This little symbol here means an avatar. An avatar is going to be used in order for us to modify or apply an animation on this body, okay? So that's the first thing. All right, cool. So going back to this then, so we want to extract my textures and extract my materials. Let's do that. So extract textures. And again, I'm gonna go to assets and I'm gonna look at textures. And instead of the folder's gonna be called textures, let's click select folder. I'll put it in the basic folder for now. And when I extract the textures, you know, my hopes is we're going to see a textured object, and we do. It says the material is using the texture as a normal map. The texture must be marked as a normal map in the import settings. Do you want to do that? Fix now. I'm okay with fixing now. Okay, and then if I zoom in here, which you can't, but if you look at the model, it looks like from far away that it's textured too, which is pretty cool. So I just did extract textures. Next, this is under the materials section. Next, let's extract materials. So extract materials. Again, I'm going to go into Assets, Materials for this one. Assets, Materials, select folder, and it's going to extract the materials for this thing. Awesome. So again, I got materials, and it says CH45 body. Remember from last time that CH45 means this guy. Let's just call this Crypto. Okay, so we know Crypto is this guy, and you notice he has a texture applied to him as well as a normal map and some emissive color. Cool. Let's go back to textures. And under textures, you can see that there's CH45 diffuse, emissive, glossiness, normal, and specular. But I don't see that kind of stuff over here. Do you? No, we don't. Why? Because we have the wrong shader applied to these material for the material. So one thing to do is in the materials folder, under Crypto, let's choose another material type. Instead of standard, you can try specular setup, but I like Autodesk Interactive. It gives me a lot more detail. Okay, so now we have normal map, albedo, as well as, if I look at my textures, like we've done this before, emissive. And we also have glossiness, right? And as well as I have a normal and specular. Let's get that specular map in there too. Now, if this isn't good and if you see some things are missing or mismatched, that's okay. We can always go back to another type of shader model, right? So let's go back into standard specular setup. Let's see if that looks any better. That's a little brighter, and you know what? It has specular in here, and I like to use my specular. Let's put that in there. And there's my specular highlights. That's what specular does. It talks about the specular highlights. We also have glossiness, right? As well as emissive. Emissive we've already done. There's our emissive, right? As an example. Glossiness could be smoothness. It could be other things, but you can see that it's not a one-to-one mapping. It's pretty good though, right? In terms of what we got going on right now. So it's a little bit glossy, and that's kind of an example of what the model will look like. Cool. And that I'm looking at the material for that. Material is right here for Crypto. The diffuse texture should be already put in albedo. Albedo is usually diffuse. Specular is specular. Normal map is normal map. If you had height map or occlusion or detail mask, it'd be here. And again, you can try some of the other ones, but I find that the standard shader, all right, that we talked about is pretty good. Standard shader isn't bad, but it doesn't have specular. It has metallic, similar, but not the same. And if I go to Autodesk Interactive, this is the other option that we can try. Autodesk Interactive has a roughness where the specular went to. That's where it goes to by default, right? And it has a emissive, but it doesn't really have, again, one thing that we're missing is the glossiness, which we can probably put in metallic if there was a drag and drop. So if I take glossiness and put it in metallic, then it'll kind of create a glossiness or a, kind of a shine to it. Again, this is Autodesk Interactive. There's different rendering modes here. We're going to just choose opaque. If you chose transparent, again, some parts of the model that are transparent would actually leak through, which is kind of cool. So what does this all look like? Well, let's bring in the model. First of all, let's see all these CH45, diffuse, emissive, glossiness, normal, and specular. These don't really mean anything to me. They don't mean anything to you. Let's rename these things as crypto diffuse, because that's what we're going to do, crypto. So we'll put crypto in there so we know which one it is. Now, actually, let's back up a step. Let's back up a step. Woohoo. Let's not do any of that yet. We're going to do it later because I'm going to bring other models in, and they're going to need CH45 1001 because they're going to use the same model, but we've changed up the names and all that stuff, and it's going to look weird. So let's just leave it as is for now. But let's bring in the model and see what it looks like. So one thing I want to do is I want to put this into its own folder under textures. So I'm going to right click and go to create folder. I'll put it under animations. And I'm going to grab all of these things and just drag and drop it into the animations folder. Okay, cool. Again, just information about the model. All right. And then the models, I have models, but I also have animations, which I have crypto T-pose. Again, maybe if you had lots of animations, you'd make a subfolder here for crypto, which is what I'm going to do. Crypto folder. Because maybe I'll have more than one type of animation I'm going to use. Drag and drop this into crypto. All right. And let's just rename it. So it's crypto with a capital C. There we go. Crypto. Save the scene. Okay, and now I want to bring in that animation, this guy, into the world. So let's do that. So bring in crypto. And what I want to do is, let's see where he is. He's here. Okay, there's crypto. You can see that the height is about right. This is about 2 meters. Remember, we talked about this. So this is what the character will look like. We want to make him bigger, we can. If we want to make that a bigger, taller character, we can do that. But crypto is pretty small right now. All right, what we want to do is we want to use this tool and we want to move crypto. Notice that the tool for crypto or the movement for crypto is at the bottom of their feet. That's a good place for it to be. I'm just going to move them into the scene so we can see them when we play the game. So we may play the game. Crypto is not going to have much. It's just going to look like this. Let's see what happens when we play and how does crypto look? Does he look right? Or does he look small? So it looks like we're bigger than crypto because we're looking at down on crypto as opposed to up at crypto. So for now, we're not going to modify this model, but if I pass through them and look back, we can see that this is what crypto looks like. All right, so it kind of glows in some places, and it's got a bit of specular highlights. One thing we want to do here when we're looking at crypto is I'm just going to go to the scene view just for a second as I move through. So one thing we notice with crypto, all right, is that he's really super shiny. And maybe we don't want to make him that shiny. Like you can see the quality of his skin here, right, is super shiny, maybe too shiny for this guy. It's not quite right, is it? Right, so what we want to do is modify the shininess. And the way to do that is going to materials, going to crypto, and where we can change the normal map values. Right now they're at like 1. Let's change this right down to like 0.35 or 0.5. That's a little better. It's not as gritty as it was before, right? I think that's a better value for crypto, right? And also some of these values, they're not something that I can control. It would have been nice to control the metallic and the roughness, But they have maps for those things, and I guess that's what the inventor or the creator wanted. But something like 0.5 for a normal map is more than enough. Okay, cool. So we've got those changes. Save. Let's go back out and make sure you say, notice that when I change the material settings, even when I'm in play mode, it changes. Let's change crypto to something else. We'll call him crypto. So crypto is our enemy. And what I want to do is I want to do a couple things here. I have an avatar, but one thing I have is a space for something called an animator controller. Later on, I'm going to bring in an animator controller so that I can apply other motions on top of crypto. All right, so this is step one. Let's save this. File, save project. And I want to put all this up on GitHub and see what happens. So pull this up and go to command prompt and do a git add dot, git commit -m, and I'll say added crypto t-pose. Git push. Okay, changes all those things. It'll be nice to have a remote. How about that? Haha. We didn't even make a remote. Let's make one. So go to up here and up on Centennial. Let's make a Lab 6 final. So I'm going to make a brand new project up here. And we'll call this Lab 6. Sorry, how about we do right? COMP397. And then Winter 2021, Lesson 6A, which is what we want, right? And I made it private by accident. Oh no. Okay, well, I'm going to fix that in a second. So copy this, all these last 3 lines of code, go to my command prompt, right click, and then press push. And it's going to go up. It's private right now. All right, well, let's make it public. Let's change that back. We talked about this last week, so you should know where to go. If you made a mistake, like I just made a mistake, who cares? It's not a problem. All you need to do is go into settings for your project in GitHub. And I'm going to go to manage access, right? And I need to log in. And if I've logged in properly, you can see that under managing access, there's a bunch of different things here. If I click manage for the repository, I can go to where it says, I want to make this public, right? Because right now, my repository name is this. I can change it, right? Here's my issues. If I want issues or projects, there's the merge button if I want it, archives, GitHub pages, as well as change repository visibility. This is the danger zone. I want to change visibility and I want to make it public. And then what it says is, please type this whole thing in here to make it public. I'm just going to copy paste and then press I understand, change the visibility. Now it should be visible to you, and I'll go here and grab this lesson, copy, go to eCentennial, one day, go to eCentennial, and then under where it says GitHub repos, I'm going to add a new repo. We're going to call this the Lab 6 Final. New, great link. Lab 6 Final. This is for you, so that way you can compare your code to my code and all that kind of stuff. I'm also going to do a couple things here on eCentennial. I want to, under the lecture itself, so under course lecture, I'm going to add in a couple of links. I added in Mixamo. I'm going to add in a new submodule under the lecture. I'm going to call this submodule Mixamo model. So this is a new submodule in lecture. And what I'm going to do is I'm going to drag and drop that model so you have it up online as well. If you wanted to do it from scratch, you don't have to work hard. You don't have to go up there. You'll just be able to grab the model, and one step at a time, I'll add in one pose after the other pose. Okay, so this is where I'm going to put it. There we go. Crypto T-pose. So you can get it inside of a subfolder of course lecture. This is where it is. All right, so that is the first one. Let's get the next one now. Okay, we're going slow, and I'm doing this on purpose because I want you to understand the process here, okay? So I'm going to go to Mixamo again. I've got my crypto T-pose. Now we want another animation. I at least need a run animation, maybe a jump animation, maybe a crouch animation, maybe a die animation, you know, those kind of things. Okay, so a bunch of little animations that I want to put together. Let's try a bunch of them. So first we'll get a run animation. So let's look and see if any of this makes sense for running. Well, this one has their hands up like this. We can also make him run in place. I recommend choosing run in place. That doesn't look right, like he's carrying something. There's also this one where he's kind of running at you with his head down, right? And that might look okay if, you know, he was going to charge at you like this one before she jumps, okay? Well, maybe this one is the best. So something that looks like this, like a regular run animation, which we've seen before, okay? If you don't like this and if you want to make him run faster like this, that's okay too. But usually it's like this kind of run animation is what you want as it's running towards you. If you want to make it faster or slower, you can change the overdrive and the speed, okay? You can also change the character's arm spacing here and a bunch of other things. For now, I'm going to keep the standard animation the way it is and click download. Cool. All right, so I got all this. It says FBX for Unity with scan, 60 frames per second, no keyframe reduction, and click download. Again, basic settings, guys. Okay, there it is. This is the next one. It says CH45 non-PBR. We're going to rename this to Crypto just to keep with our standards. Crypto at running FBX. I need a running animation. And what I want to do is as we go, I'm going to put it up on eCentennial as well. So under eCentennial, I'm going to put that Crypto running FBX up here so you can get a record of everything we're doing step by step. Again, this is for learning purposes. We're not doing anything here to make people uncomfortable or whatever. Notice that there's a difference in names. It doesn't really matter. Okay, so Crypto at running. I want to also bring it into Unity. So let's launch Unity again because I closed Unity down. And for me to do that, I'm going to get lesson 6A and then go up here and open Unity up. Now, we're going to do one animation first. All right, it's pretty dark. Let's do a couple things here, right, to make him a little brighter, right? Make him a little brighter. What I want to do with Crypto here, right, is in the material for Crypto. Notice that the emissive color, right, is HDR. I can make it so that he glows a little bit. If I choose a color, like let's say, I don't know, this kind of light blue, I can also overdrive it to choose parts of his body glowing. There we go. Parts of his body glowing. Awesome. And if you really want to, we can add other effects later. But for now, let's put him in the sunlight, in the light. And I'm just going to modify the directional light in the scene because right now the directional light in the scene is 50 degrees. Let's make it so that it is higher up. So make it at 60. Now let's pull Mr. Crypto back a little bit so we can see his face in full glory. So what I'm going to do is I'm going to take Crypto. So click on Crypto, move him back, and then the character, our character is right next to us, right there. I'm just going to turn him around so he can be seen. Okay, so I'm just going to flip him. So I'm going to rotate him across the y-axis, 180 degrees. So he can be seen by our little character, our little player here. So this way he's going to look like when we come into the scene, we should see Crypto kind of glowing, a little blue, and right there he is. That's Crypto with some glowing red eyes. Cool. All right, excellent. So far, so good. All right, very nice, very nice. I want to grab my new model. So under animations, I only have Crypto. And I have a Crypto T-pose. I'm going to grab that Crypto running and pull it in. Hello, Crypto running. All right. I need to do the same things that we did before. Under my, I have animations. So this definitely I want. Okay. But really what I'm looking for under the animations is two things, right? Under the model itself, I want it to be read and write. So make sure you read and write. The rest, I'm not going to bring this animation into the scene in any other way. All right, so crypto running is not going to be brought in here. All right, so all I need from this one, I don't need any of the other stuff. I just need read and write enabled and click apply. Right away, what you see is a couple things. You see him already. He's got his his skin. And what I can do is I can also check to see what crypto will look like in animation format. You can actually do a little animation test right here. If I go to animation folder, again, I'm clicking on crypto running, clicking on animation tab, right, as an example. And then under animation tab, I want to click loop time, this one, loop time, and then click apply. This is important. And then click play. And then you can see that, again, you'll see what crypto looks like when he's playing. And there's a little bit of a preview in the animator right here of what crypto would look like playing. Okay, so again, I'm clicking on crypto, going to the animation tab, and this is the clip, the running clip. Okay. All right, let's do the other ones now. So this is crypto's running. Nice, nice, nice. Everything is beautiful. I like it. Let us stop this now and bring in the other ones. All right, so what other thing do I need? I also need crypto being idle. So with his hands down, he hasn't seen the player yet, and then he's going to be idle. So let's do that next. So again, I'm going to go up to Mixamo, and here's Mixamo, and I'm going to grab an idle. So I've searched for running. I'm going to grab idle. Now we have to choose the right idle, right? So something where, you know, the character is idling, as in he's looking around, he's a little bored, you know, maybe he's waiting for the character, he doesn't see him anymore. If he's patrolling or if he's watching, right, as an example, maybe what you want to do is you want to put him in almost like a watchful pose, like this one. Again, there's many, many different idle animations depending on what he's got going on. Maybe you want to make him breathe more, so you want to make him kind of a breathing idle, right? Where he's kind of moving around a little bit more. That's what idle animation is, right? But, you know, again, you can be as funny or as conservative as you like, right? There's also a bunch of gestures you can download all together. Don't go too crazy, guys. The more of these you download, the more difficult the animation is going to be. Here's idle where he's looking around, right? He's looking around for the player. It's a little bit contrived, you know, as an example. And you can look at other ones. And there's ones where he's carrying weapons and one where he's not, one where he's carrying stuff, one where he's sitting down idle. And you can see that there's many, many different ones that you can choose to make the character look okay. Listening to music, cheering, you know, whatever, a drunk idle variation, a dwarf idle, and so on, okay? We're gonna make it, and here's neutral idle. Neutral kind of looks like this, where he's kind of like, you know, he's kind of standing in a weird stance there. Okay, so again, we don't want to go too crazy here. We can go and look through all these. I'm just gonna choose the first one that I saw way back here. I think that might be nicer than this one. So instead of this one, I'm probably going to choose just the regular idle animation, which looks like this. It's kind of ready. All right. Cool. Excellent. So then let's just download this one again. Click download. Again, same settings, download. I'm going to make sure it says crypto, and then I'm going to pull it into two places. So one is going to be crypto. Okay. And I'm going to pull it into two places. One place is going to be on eCentennial when it's finished. This one's a 16 megabytes. So again, they're each quite large compared to normal. Okay, just letting you know, they're a larger asset. Okay. Okay, here I am with this one. Let's bring that in, and I'm just going to bring in crypto idle. Crypto idle. And this should kind of be maybe before running, because you want to idle him first. So when he comes into the scene, he's kind of idle. So this is where this is going to be, up on eCentennial, a couple of them. Crypto T-pose, crypto idle, crypto running, right, as an example. And let's just pull that into Unity. So again, I'm just going to pull that right in. all I want to do with crypto idle, right? And again, you can check it to see what it looks like, is you want loop time on. Loop time is on. Okay, loop time means it's going to loop, right? And I also want to go into my animation or my model, and I want to have read write. I find that if I do read write, I have less errors a lot of times. Read write enabled, and then click apply. Okay, let's just do that for all of them. All right, cool. So I've got all that going on. I got 3 little animations, and you're like, do I really need all those? Yeah, probably. At least those, right? Unless you're just like doing an enemy that is very simple. All right, so cool. So I got idle, and I need maybe one more, or maybe 2 more jump and die. All right, let's try those 2, and then we're done. So I'm going to go back, grab 2 more animations. Again, go to Mixamo. I want a jump animation. We got to be reasonable about this guy, and we don't want, what we want to try and find is an animation that has very little lead time when it comes to jumping. All right, so something that is, you know, something that makes sense for jumping, not a jumping down, but a jumping while they're running, a run and jump kind of thing. Like this, running jump, perfect, running jump. Okay, so that's what it looks like, right? A running jump, okay, and download, same settings. Change it to crypto. We're just going to call this jump to make it simple. So instead of running jump, we're just going to call it jump. I'm just going to rename it crypto jump. And I'm going to pull this into eCentennial in a second when it finishes updating. There we go. Crypto jump. I'll pull it down in a second while it uploads. Good, 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 good. Nice, excellent. And pull it into Unity, please. Crypto jump. And again, I want to make it read write enabled. I want to go into the animation, and I want to click on loop time. All right. And this one we have to consider. Do I want him to jump all the time? Maybe I'll leave loop time off for this guy, for this one. So he's only going to do the animation once. So I don't want him to do, you know, jumping all the time, right? It's like he'll repeat that over and over again. He's only going to do it one time when it's activated. Okay, so this time we don't put loop time on. The rest, T-pose, obviously is the first one running is loop time. Idle is loop time, but jump, no. All right, so that's that one. Last one, die. I want him to look like he's going to die. Okay, how do we do that one? And we'll see if we can get all these, you know, kind of rigged up. So if I say die, let's just see what that looks like. You can see that there's a bunch of them dying. And we want to, you know, you can have ones that are, so this is a flying back death. So imagine if he gets hit, you know. Also, another one we may want to have, if you really want to get, is getting hit. So running hit. See if that looks like what's happening. So where he's running, like something like this, like a hit reaction, where he's running, but he doesn't have his hands up. So he's being hit on the side of the head. He's being hit on the back. You can see there's different kinds of hits. You can be really complex here, guys. And if you see what he's doing, it's almost like, you know, he's going to be, let's see if we can do this. So he's running and then he kind of gets hit, right? And it might be too much. So let's just look at something that's, you know, maybe it's not a lot. So, I mean, again, I can say hit reaction. Let's try hit reaction. And if there's not one, I'm just not going to do it. Again, you can find a lot of these motion captures online too, not just standing react. No, I want them to be running. Running is the right way to do it. So I'm just scooping down here and seeing if we can find one. I mean, theoretically we can have many, because we can have ones that he is, you know, getting hit while he's doing something at the same time as you know, he's kind of maybe idle and get hits. He can be jumped and get hit while he's jumping. Like you can see that there's a lot of animations here that can be used. I think I'm just going to go back to that running hit. running hit. Yeah, running hit might be good. This one, like maybe like where he got hit on the side of the head or hit on the back, hit on the side of the body. And you can see that he can fall, something like that. Okay, so we'll download that one. Okay, and we'll say running hit, or just hit, we'll just say hit, because the only time he can get hit is when he's running. Because chances are he's going to be running a lot. All right, so we'll say crypto hit. It's not perfect, guys, and we may not use this one because we don't have the right one. And you can see that there's issues, right? If we don't have the right animation, what do we do? Can we make one? Yes, but do we have time to do it? Does it make sense to do it for your game? No. Chances are not, all right? Because, this is a little demo that we're doing, and I don't expect perfection, guys, in any way. Okay, please don't try and make it perfect. There's so much room. If you really want to take this game further later on, after this course is done, you can certainly do that. But I'm not going to demand perfection in any way from this because it's just a little game we're going to do, and this is enough. One more, die. So we got hit, and then we get die. All right, so let's see what happens if we can find one that's a good one. So die, running. Running death. Dying. Okay, that's pretty cool. Zombie stumbling. Even though he's not a zombie, right? It's like he got hit and then he's going to take his, that's what it's going to look like, right? When it goes into it. All right, it's not bad. It's not terrible. What's death from the front? Standing death. Standing with death forward. That's almost the same. Zombies are easy. There's a lot of zombie stuff in here, right? So let's put one more thing, death, and then see if we can get one, and then see how it goes. Again, if we didn't have the rifle, it'd be pretty good, right? But death from the back. It almost like he got hurt. Death from the front. Okay, let's do that one. It doesn't seem there's one that's really one that he's running. So, except for this one, but I'm not sure if that makes sense because he's like, well, maybe it does. The only problem with this one is that depending where he'll end up, right? And it's a long step, which means you have to really kind of be careful about how this looks, especially in our game. Yeah, falling back and falling alive, eh? I think again, some of these are pretty good, and I'm not gonna be so. But the only problem with this guy is that they have something like he's holding a gun or something. This guy, maybe that guy. Let's see what that looks like. Yeah, okay, I like that one. That's this standing react death left. By the way, you can mirror. You can make it so it goes on the other side, right? So mirror does that. Let's just download this one. I'm just going to choose one, and then it's going to be an example. All right, so this is going to be death. So crypto, and then what? Crypto death. Again, you would have in real life, you can see we're doing a very simple sequence, and we have quite a few of them already. And in real life, if you're going to make a real video game, then you're going to have many, many, many of these, right? Like something like 30 would be an average, right? You're walking left, you strafe left. You walk right, strafe right. You know, especially if you have a controllable character, not like this this character we're making. You could have many, many different ones that you hook up, you know, that we're going to talk about in a sec. All right, so that's the next one is, let's put it up on eCentennial here, so you have it, so you can, you know, for your own learnings, you have it here, hit and then death. That's okay, I'll pull it down. And now you have all the ones that we're going to use. All right, so now you notice how many we have. We have T-pose, which doesn't really count. We have 1, 2, 3, 4, 5 animations. And I would say you need probably 6 times this to make it look nice, right? You know, in a professional kind of way. You guys aren't, I'm not expecting perfection from you guys. So totally cool just to have, even this is going to be great. Okay. Awesome. Let's put it into Unity, the last one. So we have crypto death. Did I even spell crypto properly? I did not. That's okay. Because we don't care about it. We don't care about this. We care about the pose. Crypto death is not going to be loop time. That's for sure. It's only going to happen once. And the model is going to be read write. Definitely make that read write already. So crypto death, apply. We want to definitely make crypto death rewrite, apply. And let's see what it looks like when I go to animation and track them out. So there it is. So kind of like that weird arm there. That was kind of the one thing I don't like about them, but whatever. All right, so I've got all these animations. That's step one. And I've given you them up online. Now, how do I use them? Well, first steps first. Let's make this crypto guy a prefab. So I'm going to go to Resources, Prefabs, and drag and drop crypto in here, like so. It says, what do you want to do? You want to make an original prefab or a prefab variant? I want to make an original prefab. Crypto. Awesome. All right, great, great. In crypto, I have something called a controller. This is the animator controller, but we see that there's nothing there. Let us add an animation controller to this thing. So under animations, under crypto, let's add a brand new asset. Right click, I'm going to go quick create. Underneath that, you're going to go to animator controller, click create. And I'm going to rename this to crypto, if I can spell properly, animation controller. Crypto animation controller. Awesome. Excellent. This is going to be my animation controller for crypto. All right, so what is an animation controller? The state machine. So under crypto, I'm going to drag and drop this crypto animation controller where it says controller. Just drag and drop it in, please, like this. So now the controller has something in there, which is the one we just made. What does this look like? If you double click on this, it'll bring up a window that looks like this. If you don't have this window, you can always get it by window. And you want to go to animation, and you want to go to animation. Animator. That's the window, animator window. And we see that we don't have any state in here whatsoever. There is an any state, an entry, and an exit. This is visual language where you don't need to do any code whatsoever right now. We have also something called layers we're not going to use today. Parameters, which is going to be a variable we can trigger. I'm going to do things differently than some of the stuff you've seen online, but it'll be very simple. And then we have a couple of additional things here. Okay, what we need, I don't need the entire folder here that we just downloaded. All I need is to apply the motion, the clips. Let's drag in the clips in there. The first one I want to drag in is idle. So I'm going to open up the crypto idle, and down in the bottom where you see this little idle animation that has a little triangle with some speed on it, looks like, drag and drop this to here, like so. Immediately you see a new animation. There's an entry and an idle. So this is the animation that's going to come in. All right, we have enough. Let's just do that. So again, all I went to is crypto idle. I opened up the animator that I created, right, that I connected to crypto. Here's crypto's animation created. I have a crypto avatar, that's important, and I dragged and dropped the idle animation into the animator. And once I did, there's something called entry. It created a line for me from entry to idle. I want to save my scene, and then I want to run my program. And let's see what happens. Do I get an animation or not? And yeah, look at that. There's my little idle animation. You can see it immediately takes shape. So it's modifying his bones, right? And I see that he's got shadows happening and he's modified. He's no longer in T-pose. He is idle. Okay, it's pretty dark too. Cool. Awesome. All right, let's, so no, he's normally like that, but when I run it again, you can see now that I've added in that little animation, he is in idle format. Okay, cool. Excellent. I like it. Now, let's add in the other ones. Again, I'm going to go into my animator, and I have my idle animation, and I'm going to go into the next one. I'm going to go from idle to run, right? So I'm going to go to running, and let's grab running and put that in, pull that in. You can see now there's an idle and a running. Running came for crypto running. There's a little triangle, this little triangle here. It's a clip. That's what it is, an animation clip. I'm pulling it in. And what I want is a transition from idle to running. So right click on idle, make a transition, and then connect it to running. Again, this is your state machine. All right, so from idle to running. I right clicked here and then click make transition. I can do that. I also probably want to go from running to idle. Let's say he loses you again, right? There should be a way of going back. So I want to go from running back to idle, right? So there's a transition back. Let's think about this as a directed graph in some ways, right? Where if I only have an arrow going in one direction, there's no way for the arrow to come back. So I can't go back. If I didn't have this, there's no way to go back to idle when I start running. We may not want this one. We may not want this transition at all. Why? Maybe as soon as the way it's going to work is the enemy's going to start idle. They're going to detect the player. As soon as the player is detected, they're going to get the player's position, and then they're going to come at us. Different way of animating, a different way of doing things. Okay? So maybe we don't need this one on the way back. For now, we'll leave it. Okay, next. What about when the player or the enemy jumps from one scene to one part to the other? Remember, when I bake this scene, I'm going to have, as an example, different places where the enemy can jump, right? Well, I want to be able to transition from a run to a jump. So going back to Animator, I'm going to bring in, go to jump. So again, going to the jump animation and drag and drop jump in there. Okay, and then you have jump. So I want to go from a running to a jump. So run to jump, and then I want to go back from jump to run, right? Let's just do those. Okay, I brought the other ones in there, and the hit and the death pose, but let's just do those for now and see what we can do. All right, so now, a couple other things to note. These lines, what they are is they're actually doing, having blending. We're going to go from running to jumping, from idle to running to jumping, right? And they're going to blend from one type of animation to the other. And notice on the right, there's something called, for this line, from idle to running, there's something called exit time, has exit time. Has exit time means I'm going to wait for my idle animation loop to finish before I can go to running. I don't want that, so I'm going to click that off. And same thing goes from running back to idle. I want to go back from running to idle, click off has exit time. And the same thing goes from running to jumping. I want to take away has exit time. And the same thing goes from jumping to back to running. Take away has exit time. Save. So has exit time means you have to finish your animation that you're in the middle of, and then you can do something else. We don't want that. We want to immediately go from one to the other. Cut, almost like. All right, here's another thing. The blending is pretty big. Like you can see that I'm going to just drag this a little smaller so you can see it here, and move this over here, and move this over here. You can see that this is the blending curve that's going on right here, right? So what's happening is we have idle, 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 idle. It goes for about a minute and 25 seconds, how long the animation lasts for. And then if I go into idle, it's going to have the last bit is going to transition for almost 5 seconds. That's way too long, right? we want to drag that really much lower. And what I want to do is, if these things are draggable, so this thing is draggable down here, and so is this. I want to drag this so it's like really right at the end here. Okay, that's what I want. And but for this first, what I want to do is, if I zoom in here, you can see I have little control, and I can zoom with the mouse scroll wheel. I have little control handles here. What I want to do is I want to drag this really, really tight where it says like 99%. Okay, so again, I went from here and I went to 99%. I want to take this not running and then drag it all the way down to here, right? Where it's like literally nothing. And on the right, I want to drag this in so that there's literally no other running. It goes from running or from idle to run, and there's nothing, no other idle back here. This reduction in blending time makes it so it cuts directly from one type of animation to the other, which is what we want here, okay? Sorry. To create animations. I'm not creating animations. I'm using Mixamo. This is I'm just answering the guys online on YouTube. All right, so that's kind of cool. So I'm going from idle to running. Okay, let's how about running to idle. Same thing. Again, you can drag and drop here. And what I want to do is I don't want to have from running back to idle very big. So again, I'm going to drag this all the way to 98 or 99%. Let's say 98, 99. I'm zooming in here, and then I want to drag this in so it goes this way. And I'm going to drag this all the way to the end. There we go. So it's really tight. Running to idle is like there's literally no time. I've really reduced it to nothing. This is blending, where I blend the motion from the model, all right? Cool. All right, I want to go from running to jumping. Same idea. Let's do it again. So again, I'm going to pull this all the way down to the right, and it's going to go right down to about 98%. And I'm going to move this in to about just under 100%, and then pull this right down to where that is, so that both of them are lit up like this. You can see that. And the same thing on the way back. All right, so again, move this all the way to 98%, 99, something like that. And then move this back in there so that it's just underneath 100. There we go. And then pull this to the right until they both lit up. Okay, lit up means they both kind of are white. Great. I've done everything here. I'm going to save this, and you should have 3 states: an idle state, running state, and a jump state. And that means I have 3 triggers, if you will, that I can set up. I can set up triggers for this, but I'm not going to do triggers. Instead, I'm going to try something else, because you've probably learned triggers if you did some tutorials online. I'm going to choose parameters instead. So I'm going to go to plus, and I'm going to add in an integer parameter. And I'm going to call this the anim state. Anim state. That is the parameter that I made. So I clicked on parameters, clicked on this little button, and you can choose different kinds of parameters: a trigger, a bool, an int, or a float. I'm going to choose int. Cool. All right, anim state is the parameter. Okay, you don't have to do it this way. You can do it the other way, however you want to transition. But this is going to affect how I do my code. I'm going to start off in entry. I'm going to go to idle. I'm going to idle, and I'm going to be able to push the player from idle into running, from running to jumping and back. Okay, we're going to have little triggers, keys to do that for us. Before the actual object moves at all, we're going to do it programmatically. Cool. Idle to running to jump and then back. Okay, that's what I want. So from idle, if idle is the 0th state or the initial state, I want to go from idle to running. And if I click on the transition on the right where it says conditions, I can click plus, and I can choose anim state, where anim state is equal to 1. Right? When anim state equals to 1, it goes from idle to running. When anim state is equal to 0, it goes from running to idle. Running to idle. So let's say another animation. Anim state, right, equals to 0, goes back. Okay, how about this? Can I go from jumping to idle? Maybe in a real world I would, but even this animation going back to idle, I don't even see how, right? But definitely jumping to idle, I don't know. Right? I'm not going to make it possible. You have to choose your animation loop the way it works. Right now it goes from idle to running to jump, and then back to running, and then back to idle. The only way to go back to idle is through running. Okay. All right, from running to jump, this is 0 and this is 1. This will be 2. Again, notice how it's hard coded. This is the negative. But we're going to fix that. Equals to 2. So 0 to 1, 1 to 0, right? 1 to 2, 2 to 1. Okay, pretty simple. So all I have to do is somehow programmatically change this anim state variable, right? And if I change the anim state variable, I can move the character animation from one state to the other state. Cool, we saved everything. Hopefully you have what I have. And then I'm going to put this up on GitHub in a bit. And then what I want to do here is do some programming. Okay, we have our crypto prefab. Here's our crypto prefab, right? And he's pretty small. I'm gonna boost this guy up in a second. He's gonna be taller than this. He's gonna be much taller. He's gonna be scary looking. All right, in a second. But the way to do that, and I can do that now if I want, by the way. If I go from a scale, let's make this, he's like at 1. Let's make it 1.5 times as tall and as wide. There we go. So that is kind of closer to what it was before, right? And if I look at the actual character right now, you're going to see him. He's just an idle the whole time, but he's pretty big now. It's pretty much our size. Okay. All I've done is scale them up. There we go. All right, cool. So that is all I've done is scale them up. I'm going to save that. And now what I want to do is some kind of behavior. Let's add in 2 things. I'm going to add a Nav Mesh Agent because this guy is going to be something I want to duplicate. So I'm going to add in a Nav Mesh Agent. Here's my Nav Mesh Agent, right? And we're going to make our height, because it says 2, right? He's not quite 2. Let's pull this height a little lower. So he's about 1.9, maybe even a little lower than 1.9, but 1.9 is about right. 1.9 meters tall. So he's a little taller than 6 feet, let's say. 1.8 is like 6 feet or something like that. Oh, the average height. And his width, notice his width, that is a pretty big width for this little guy. So this is where you can play with the radius of the obstacle avoidance stuff, right? So I can say that the radius is much slimmer. He's way slimmer. It's like 0.2, let's make him 0.25. All right, that's pretty good. So now you can see that that makes sense for him, right? Because he can probably skinny through, you know, most things because he's skinnier, a lot skinnier than the enemy was before. All right, that's my Nav Mesh Agent. Okay, it doesn't have a direction right now, but I wanted to add it in because it's going to be part of the prefab. Let's add that in, override. Let's go apply all to add my Nav Mesh Agent in there. Awesome. Okay, next, let's add in a script to control them. So scripts, I'm going to call this crypto behavior. So right click, I'm going to click create. I'm going to go C# script, and it's going to say crypto behavior. There's crypto behavior, right? And I'm going to attach it to crypto. Again, I could have made enemy behavior the one. I'm not going to, just so that we have separation. And one thing that's missing from this this guy here is a marker. Let's get that enemy marker from our materials folder. So I want to add an enemy marker. I'm going to right click and add in a new quad, right? Because we don't have an enemy marker. I'm going to do it. So I'm going to go 3D object quad. And let's bring it so we can see the markers because I've turned them off. We're going to see them now. And the quad is going to be rotated around the x-axis 90 degrees, like before. There's my enemy quad. Let's actually make it -90. There we go. And just like before, I want to bring this enemy marker up so we can see it above the head of the character. Right, there's my enemy marker. There we go. My figuring is about 1.8 1.9, where I think we should put it. And remember, I need a material. I'm just going to use the same material that I used before, which is enemy marker. I should be able to just reuse the material here under materials, enemy marker. And this enemy marker, it should be called enemy marker. We should probably have made that a prefab. We didn't. That's fine. I'm going to change the layer to marker, right? And I'm going to change the layer from crypto to enemy. All right, I want to make this the enemy layer. So, or the crypto itself is going to be enemy, but only for crypto, not for the marker. So let's just say change children, and then I'm going to change the marker back. All right, yes, change children, go to enemy, and then let's change the marker back to marker. Sorry, it's just easier. All right, so now he is got a couple things. He's got a marker, right, as an example, right? He's got a, he also has a behavior, right? And this is pretty cool. The only thing with the marker is it looks like it's pointing in the wrong direction. Right now it's pointing like this way. The marker should be the other way. So let's just take the marker, enemy marker, and rotate it around the y-axis 180 degrees. There we go. So now it's positioned correctly. And save. And I want to go to the crypto prefab, and I want to go to overrides. And again, I want to say apply all. There we go. Now the crypto prefab, every other prefab is going to be just like this one. And I don't care to see the crypto marker. So again, I'm going to go back to layers and turn it off. But I just wanted to put it on there so we can see it. Awesome. And if I run it now, we should be able to see crypto on our mini map. So here he is, and press my mini map, and what? How come I can't see my crypto? How come? Well, there's a couple things. One thing is that, first of all, we have to make sure that the enemy marker is marker. Cool. And we also want to make sure that crypto is on the enemy layer. That's good. Our player cam right now, when it comes to culling mask, should not see marker, but should see everything else. Okay, so that's where it should look right now. Everything else except for marker. Enemy is something I should be able to see. If I turn enemy off, I won't be able to see him either. Watch. See? It disappears. So, and if I turn on the marker, right? So if I go mixed, and if I go turn on the marker, I can see the marker when in the player camera, right? But I don't want that. I want not see the marker. But in the player minimap, the minimap camera, so if I go to minimap camera can see the marker, but not the enemy, right? I can see the marker, but not the enemy. So where is it? Well, he's underneath this thing because he's in the underneath the underpass. Let's pull him out so I can see him a little better, just so he's closer to me anyway. So again, I'm going to choose crypto, and then just pull him closer. So he's not underneath this thing. And then if we go back to the player, and if I look at the player marker, or the minimap camera, then you can see that we can see both. One thing is that crypto's minimap marker is pretty small. Remember, I made it like 1.5 times larger, even for the player. So there's my player marker, it's 1.5 times. Let's do the same thing with crypto. So enemy marker, we'll say 1.5 times. And then again, I'm going to go to crypto themselves and go to overrides and click apply all. Apply this overrides thing. What it does is it applies the changes to my prefab. So all of them, when I pull them in, have the same stuff. All right. So now if I run it, I should be able to see him much closer to me because he's right in front of me, right? And he looks pretty good. He doesn't have a collider, right? Because I haven't added a collider on crypto, right? If I want a collider on crypto, I can put one in, right? But I'm not going to do that at this point, right? So, and if I was going to put a collider, notice that his skinned mesh renderer does not have a collider. His hips are it's for all his entire rig is right here. So really, if anywhere, his skinned mesh renderer, which looks like this, right, is got, I can have bounds for the skinned mesh renderer, and these boundaries are how kind of wide the mesh is. That's okay, but what I'd like to do on crypto is, if we're smart about things, his Nav Mesh Agent has a structure when it comes to obstacle avoidance, but not for collision detection, right? So what we want to do is let's add in a collision collider. So I'm going to add component. Actually, I'll do it inside of the prefab this time. So I'm going to go to prefabs, and I'm going to go to crypto, right? And if I double click on crypto, it'll take me into prefab mode. So this is if I'm in the prefabs themselves. So this is kind of where you can do it, and you don't have to worry about opening it up or anything. So in crypto, here's crypto, right? What I want to do is on the right, I want to add in, and I'm going to the top of crypto themselves, the crypto up here. I want to add in a new component called a collider, and I want to add in a capsule collider. That might be the best thing to do. Capsule collider doesn't know what to do, so I'm going to kind of put in some bounding areas, right? And you can see that the capsule is this way, and it grows this way, as well as the top. There's a little mark right there. You can see that it grows on the top there. So what I want to do is the height, I want to make it so that it is, it's going to bound crypto, right? Now notice that the height is kind of in the middle, and the offset, the center should be 0, 0, 0. If I go 0, 0, 0, what it's going to do is going to go right to his feet, right? Because there is no center. It's like right there. This is the center for him. So I need to offset the center on the y-axis alone by, because we're making it like 1.9. So make it like either 1 or just less than 1. So 0.95. That's the center, right? And instead of making it 2, let's make this 1.9 for the bounding area. So it's just above his feet and covering his head. Now let's make it 2. There we go. It's probably going to be. And now from a radius perspective, it doesn't have to be this big. Remember we said like 0.25? That might be okay for the bounding area. So again, this is the collider. So when he collides, he'll collide. All right, and we'll see if that messes things up or not. All right, so now if I run it, let's see what it does. Does it do anything? Nope, still pretty good. Okay, but now if I can collide with him, see, I can't go through him anymore. He's gonna collide with me, right? That's pretty good. That's what I want. I don't want to go through them. And they shouldn't be able to go through each other. And I make more than one of them. Okay, cool. So now that I've done that, save the scene. Let's go back out. So this going back, teleporting into a prefab is just double clicking like this, right? Teleporting out of a prefab is going to this little left arrow over here. So out now and back up to normal. There he is. He's pretty good now. Okay, now we need some code. So let's do the last part, scripts. I'm going to make it so that there's no Nav Mesh Agent yet. All I want to do right now is I want to make it so that crypto can animate if I press a button. All right, so let's do that. So I'm going to go into his script. Oh, you know what? Sorry, one more thing. In the animator, hold on, in the prefab, let's go back to crypto for 1 second. I want to move the Capsule Collider up. So you do it in the prefab, not inside the hierarchy. So again, here, I'm just going to move this up. There we are. So now it's, and then let's move it even further up, closer to the transform. So it should be like transform, animator, and then Nav Mesh Agent. So move up here. Transform, animator, Capsule Collider, Nav Mesh Agent, crypto behavior. This is good. Because the bottom is where the script, my custom script is going to go. Okay? Back out. Okay, cool. So now you can see that if I click on crypto, sure enough, that's all moved around. All right, now in crypto, I'm going to double click and bring up Visual Studio. And I need some keys for this, right? One is I need to be able to capture his animator controller, right? So the way to do that is I'm going to make it private because I don't want to see it, right? And I want this animator controller. It's called Animator. right? And we're going to call this Animator, right? And I'm going to make a reference to it. I'm going to say that in start, I'm going to say Animator is equal to get component. We're looking at, sorry, it's going to take a second for my resharper to sharpen up. Come on. Get component animator, all right? So I want to get component animator. And what this is going to do is get a reference. For now, if you want to see that, just make it public for now. We'll make it private again in a second. So in runtime, it's going to detect the animator component that's in here in the prefab, right? So I don't have to do it for me. So that's the first thing. So run it. And then there's my animator component, right? It's got the animator right here in crypto. There's the animator controller. That's what it is. Awesome. All right, cool. Back to code. Let's make this private. We also want to get access to Unity Engine UI. So using Unity Engine.ai. Sorry. I want to get access to, let's make it public for in a second. I want to get access to the Nav Mesh Agent. So Nav Mesh Agent. We're going to call it Agent. Okay, just keep it simple. And we're going to do the same thing. Say agents, that's equal to get component, Nav Mesh Agent. Okay, we did that in start. So when starts, we get all our references. And let's see what happens when we see it in Unity. So again, we're rigging it up. There's my Nav Mesh Agent. You can see crypto. It's pretty cool. Excellent, excellent. I like it. So we got references to both those things. Now let's make an input system just for testing. So we're going to say if controller, because this is the animator controller, animator dot, and I want to set integer, right? Remember we had an integer. It's called anim state. I want to set the integer and look at the name. This is one of the things. It says, tell us the name of your controller, of your parameter. So the name is anim state, and then the value, right? As an example, is what I want to put in. So that's what if I want to detect what the current state is, right? But what I want is instead is input.key down, and we're going to say from idle to run is the we can't make it the R key because that's being used right now. We'll make it the U key for now. Okay, we're gonna get rid of this in a second. This is just for testing. So again, the U key. All right. If input.key code U, well then that means that we're gonna say that our animator dot set integer to that's called anim state to 1. But we're never gonna remember 1. So it'd be really cool if we had a little enumeration, which I'm going to put inside the class itself. So we're going to make a public enum in here that I'm going to call this crypto states, or crypto state is what we'll call it. And 1 will be 0 will be idle, 1 will be run, 2 will be jump. Okay, so those are the animations. I made a little enum called crypto state, idle, run, and jump. And all I want to do is I want to convert it into an integer. So I can say that crypto state and then dot run. So it's descriptive, but I want to convert this into an integer because that's what it needs. All right, so it's going to basically just use run. So it's going to be 1. So this way we don't have to remember what the number is. We just know that 1 is run. Cool. That's when an input.get key down U. And what about if I want to go back to, if I want to jump, input.get key down. These are just testing keys. Key code.j and say it is going to be jump. So let's copy this. Actually do it in the right place. Anim state crypto jump. right? So I have to put the number in there. And then finally, the last one, I'm just going to copy this whole thing where I want to go back to idle. So we'll say key code I is the idle state, which takes us back to idle. And if just for completeness, we want to probably put this first, just because it's starting at idle and we can get it to kind of put it in the right order. Idle, run, jump. Yay, some key codes. Are you with me? Check mark if you're with me, X if you're not, far away, you're just watching, that's okay too. Hey, Kautuk and Eric, you guys are following along. Thank you so much for that. And hopefully there's other people watching too. All right, thank you about that. I want to clear all. Thank you for that. All right, so let's try this out now and see if I can get them to move from one thing to the other thing, right? And back. So how does this look? I'm going to make sure it runs. And he is idle right now. And there he is. He's idle state. And remember that I want to make him run. I'm going to press U for running. There he is. That looks pretty good, right? I is back to idle, right? And J is jumping. J is jumping. And look at that. Idle to run, no problem. Run to jump, no problem. I can make him jump, right? See that? Idle to jump, right? But isn't that weird what happens when I make him jump, right? He jumps and other weird things happen. Okay, let's take a look at that because he's doing something that maybe I don't want him to do. So I'm just going to go back to Mixamo and let's take a look at jump again. Again, I want to be very careful how things are working because remember that we want him to jump in a very kind of a running jump is what we want. So that's kind of a running jump, right? And you can see that there is no run in place. Like he's always jumping, right? So he's running and moving. So his animation is actually going to make him move. I got to be careful about this. So as soon as he hits the state, he's going to actually do his motion. So that can look really weird what's going to happen. And I got to compensate for this, okay, for this motion. What I mean by that is if it was just jumping in place like this, right, then that's okay. But then you see there's a crouch and then a jump, right? And that's really too slow. I'd have to make that like really overdrive a lot. So, and that doesn't look right. It looks too fast. So then I'd have to do something like this. And it has to be really quick on the startup because he's running most likely, right? So that's kind of we're going to have some issues with the jumping for sure. This is the jump and that's like leaping over something, that kind of jump. Okay, so again, we're going to have some problems. We can also have chosen this one, right? Which isn't a bad one, but now what I like with this one is that it's in place. Look at that. Why is this good? Because we're going to have motion from it. I think this might be better than what we did before, right? So I may want to do something that looks like this. And we may want to just cut this down just a touch. So I'm going to go overdrive back to see what it looks like. Nah, that was better the other way. Maybe even faster. Okay. You guys don't understand what I'm talking about, but we'll see. But I'm going to bring this guy down and do it again because I don't like that jump animation. All right, so again, FBX for Unity with skin, 60, none, download. And we're going to say jump 2, just so that we have both the other jump and this one. So we can keep the other one in there too, just in case. So again, I'm just going to choose jump and just put jump 2. I also want to put jump in there for you guys too, so you can see the difference, okay? And then so you can decide which one you'd use if it was you. So there's jump 2. I'll put that up here. So an alternate jump, right? Because jump 1 didn't quite look right, right? Something's not right with it. And I'm afraid it's going to have a problem. Okay, so how do I replace now an animation? I already have some animations in there. But remember, crypto doesn't care, right? All he cares about is that we set this up properly. So here's crypto jump 2. We know we have to go to the model. We know we have to turn on read write enabled. That's kind of a helpful thing, right? Here's read write enabled. And then what we want to do with read write enabled is we have to redo the state machine in a second, right? So let's go back, and I want to go to animation. This is the animation here. And I want to pull jump 2 in there in the state machine. So in the animator now, instead of jump, let's pull in jump 2. There's jump 2. And let's just get rid of jump. So get rid of jump. We have to make some adjustments. And then let's make a transition from running to jumping, from jumping back to running. We don't want it to have exit time. So we're going to go from here to this. Again, this is 0, 1, 2. We need to put the condition back in here that it's equal to 2. Equal to 2. We don't want exit time. We don't want exit time on the way back. So you can see this whole process again, so that you've seen it more than once. There we go. Now we need to adjust the blending modes, right? Because we want to go from this down to 90%, 98%. There we go. I want to move this one back so it's here. And move this one back to 100. Good. And then do the same thing on the other way. Again, we want to blend this way back to 98. So very little blend, like 2% blending is what we're talking about here, guys. There we go. Looks about right. And save. And let's try this jump now. Everything else is the same. Nothing has changed. Let's see what it does now compared to what it did before. If it messes us up. Remember, we have the other one still, right? Run it. All right, cool. And we'll back up a little bit so we can see him a little bit more. And let's make him so he's running. And then he is idle and back to run. And then he's going to jump. Oh, what the heck is going on? He's suffering so much that he's going back and forth, right? And why is this happening? Why is this happening? Why do you think this is happening? He's going to a seizure, is what it looks like. So obviously something's not right, right? Well, let's see what the jump animation looks like. Okay, that looks nice, right? After jump, it has nothing to transition back to. Right, okay, let's fix the animation problem, right? So again, let's stop and let's go back to my animator. And let's make sure this is right. So running to jump equals to 2. Jumping to running can't be equal to 2. It's got to be equal to 1. There's our error. Just wanted to show you that. And then see what happens now. Again, little tweaks here, and you're going to see we made a mistake. All right, let's see what happens. And let's go from idle. Can I go idle to jump? No. Can I go idle to running? Yes. Can I go running to jumping? Yes. And then he's back to this, and then he's going to go back to running again, right? Like this. So from here, and then just go back to running. Here, and then back to running. That's what it's going to look like. I'm pressing the keys to make it happen. But that's what it's going to look like. A little jump, and then it's going to get back to running. And then back to running. And then back to running. Okay? And then it's going to go back to idle eventually. Cool. That's the way the animation is going to work. I like it, kind of. Now we have to make a trick. All right? So we need to make it so that the character is not automatically detected, right? So the character can be seen, right, when he's close enough. And a lot of games do this. There's a lot of ways to create a radius, the detection radius, right, for crypto. So how to do it? So we could use array. Okay, so let's just draw this out. So imagine if, and here on my drawing board, right, I have an object. Here's my enemy, right, and my player is, there's maybe some kind of obstacle, right, as an example. And maybe some other obstacle over here. I'm just looking at it from the side view. Okay, let's suppose. And I have a character. This is my character. My character's over here, right? Well, if my character's over here, let's suppose my enemy has a line of sight that goes from here to here. So here, enemy player can't be seen. What you could do is you can make it so that, and again, I'm just talking about this so you understand that there's options here. I can make it so that when the player wanders around, jumps on this obstacle, and then goes here, he gets seen by the enemy, and then it triggers the his pathfinding to begin, right? That could happen. Okay, or, and this is like a single line to do this, right? But the problem with the single line thing is it's only where the character is looking. So if, let's suppose, and I'm just going to draw this out here again, let's suppose that not only is the enemy here, but this is his head, and they're looking this way. Okay, only if the character is looking this way can they see the player, right? As an example, if they're looking this way, can't see the player, and only exactly in front. From a top-down perspective, if I was going to draw this from a top-down perspective, right, then it would look like, I'm just going to draw it over here, top-down, okay? Here's top-down. So here's the player, and here's the player over here. Top-down, this would be like, maybe something like this, right? And then what would happen is, this has got the same line, but look how thin it is. It would be something that looks like this. Okay, so this is the character, top-down, right? This is side, top, right? So let's label this so you can see what I'm talking about. I'm drawing it because I want to explain it before we do it, right? Side. Doesn't matter which side. Probably the right side, okay? And again, if I was to move this character around, so let's suppose I move the character now, right? So, hold on a sec. Let's suppose I move the character around, and so he goes to here, and then he's there, then that's good. But what about if he's over there? What about if he's over here? What about if he's over here? Somehow this guy doesn't see him? Doesn't make any sense, right? Doesn't make any sense at all. So sometimes what we want to do is create a field of view, right? Field of view. You can use a shape. Like, for example, I could use some kind of shape to make this a custom shape, like that I want. Again, what I could do here is I can make it so that it's some kind of triangle. So from here, let's say to here, and then from here to here, and then anywhere, if the player is anywhere in here, right, then they can see him. So he's here, 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 here. It's more like a volume as opposed to like a line, okay? And this is great, but we're gonna even make it simpler than this. We're gonna make it a box. And the box is going to come from here, and it's going to go like this. All right, so the box is actually going to do this. That's what the box is going to look like. Anywhere where this character is facing, where there's a box, and it's a box project, right, from the character, to the player, it can detect them. All right, so that's how we're going to do it. So in other words, we have to go back into our code for the agent. Right, and let's make it so that the agent's nav mesh is now private. We don't care about that. And I want to have line of sight, and it's going to be something that I calculate in the update. So I'm going to say something like var line of sight, right? That's what it is. Line of sight, or LOS, is equal to, or field of view. You can also say field of view is equal to a physics. And I want a raycast, but there's a different things we can do. We can do a box cast, physics.boxcast, and the physics.boxcast we can do, right? It's going to, there's different overloads for this particular thing that we're asking for, right? Okay. So notice what it says: center, half extents, direction, and orientation, plus a maximum distance. And there might be other ones in here where I have a layer mask and something else. Okay, so that's the box cast. So it can be quite complex to fill in, all right? Or it looks like it. There's also checkbox. Checkbox is center of the box, right? Half extents, quaternion, and then some kind of layer mask. All right, quaternion is the orientation. All right, so that's something we can look at as well. Well, before we go there, let's just comment this out for now. This is the idea that we're going to do, right? I want to use on GUI, all right, because, or not on GUI, on gizmos, on draw gizmos, right? Because if you look at Unity, remember we did this last time for our player, right? Our player, if I look at the assets and if I go to scripts and if I look at the player behavior script for here, you can see that we use something called on draw gizmos. Let's take this whole thing again, this on draw gizmos thing, And let's see if we can draw the gizmo before we actually do any kind of checking. All right. So instead of draw wire sphere, I don't want to draw a wire sphere. I want to draw, right, a wire cube. And I want to draw from the center to some kind of size. Okay, because I want to get you an idea of how this works. All right. Size is a vector 3 size, X, Y, and Z attributes. Okay, so center would be the character's transform. All right, and let's make this wire cube orange so we can see it in all of its weird color, or I don't know, some other kind of color like yellow or something else. All right, but something that's definitely, or magenta. Let's make it magenta, something that we can see. All right, and so here's the draw wire cube. The wire cube center is going to, let's suppose it's the center of the character. This is why I'm telling you we have to do this. Then I want to do a transform dot position. That's the center. And then our vector 3 size is a new vector 3 object. And we're going to say that X, Y, and Z coordinates wise, on the X axis, that's in front, let's extend it for, I don't know, 20. And on the Y axis, that's up, we're only going to go 2 meters up. And on the Z axis, that's the side, we're only going to go about 2 meters wide. Okay, that's what I want. So let's see what this draws like before we do it, because this is going to give us an indication of what it's going to, what the enemy can see. Again, I'm using on-draw gizmos for this. This is going to help us visualize. All right, so yeah, wherever it decides to draw it, it's going to draw it, and there it is. Oh man, what the heck? Why did it drew the line this way? Why? Right, well, this is the x-axis, right? Relative to this, this is going to be the other way. So we messed it up, right? We want it to go on the y-axis. So this is the z-axis. We don't want the x-axis. So let's switch these around. So this will be 2, and the z-axis will be 20. Oh. All right, and let's see how that looks like. All right, so that's kind of the narrow bit that it can see. Do you think that's wide enough? I don't know. I think it's a little bit too narrow, and it's pretty long. Like 20 is like this whole thing. So I can see the character no matter where they're looking, right? Where it's looking, you'll see the character. So let's make it even shorter, a very short vision, like a robot. 10 from here, 10, and then we'll also make it so it's a little wider. So make it like 4 wide. So again, 4 wide means X on the X-axis 4. This will be 10. And then now, again, while we're doing is visualizing, we haven't done the actual look. Okay, so this is what it's going to look like now. All right. So, and you can see that if I go to crypto, and let's just raise crypto up. So you see he's got a bit of problems, right? Crypto's is centered around the bottom of his center, right? His center is not there. His center is, so it's somewhere like down here, right? That's the center. We need to move this up. Again, remember there's an offset of about, let's say 1. If I move his center up to 1, so let's say if I go, I want to move this up to 1 higher, it's going to go to like here, right? So I want to move this up to 2, all right? So an additional 2 up. Okay, let's try this out. So instead of on 2 on the Y, we'll make it 4 on the Y. Okay, that's not what it's going to do. It's not going to do it right. Okay. So let's do it instead of 4 on the Y. Let's move up the transform position. We'll also move it up +2, plus new vector 3 object, which is going to give us on the x-axis 0, 0, on the y-axis 2.0, and on the z-axis 0.0. So we're just going to give this offset. Again, this is important understanding what's happening here. Nice. Okay, so that is more like it, right? That is the cube, okay? But now we also have to push it forward because the middle is where you're supposed to be at. It's going to start here and not from the middle, but actually it's going to start here. So it's going to push this way forward, right? some amount. Okay, so that means on the x-axis, right, let's add in, let's say 5 on the x-axis. So we're going to just see 5. Let's see if it's 5. And it's on the x-axis or the z-axis? I think it's on the z-axis, sorry. On the z-axis, let's move that 5. All right, and let's see what happens. -5 on red. I know, let's see. Give me a second here. All right, so that was the wrong way, right? And let's go the other way around. So it's -5, like you said, right? Because remember, it goes into the screen, not out of the screen. And now we get an idea of what he can see. So this is anything inside there is fair game. The player or the enemy can pretty much see anything in there. It means if I'm over here, you can't see me until he looks over here. Okay? Or until I cross into his vision. All right, so that's how it's going to work. But now that we have this idea and we have some information here, let's set this up in separate pieces. So we're going to say that this is offset, var offset is equal to this new vector3 blah, blah, blah. Okay. And I want to take this and make this offset plus some offset, because that offset is the thing I need. And this is the size, right? So I'm going to say var size is equal to this. So this is the size that I want, right? So it makes it look a little neater. And that gives us an idea of numbers we can use. Okay, now back to this. So we want to do the same thing. We want to do a checkbox, right? And it says half extents, right? This is interesting. Some kind of orientation, a layer mask. Okay, or we can do a box cast, right? So again, there's different ones. There's box cast, it says half extents, right? There is checkbox, and there's also a direction. So a direction is forward. So a transform forward is where it's looking. That's the direction, right? Half extents. And what we should probably do, guys, is get a reference to this in Unity. So we're going to do a box cast. Let's look it up. So physics.boxcast Unity. And let's see the difference between boxcast and boxcast all. Sometimes they'll have a little script that can help us out, like this. So, okay. So it says hit detect is collider.bounds.center. That's the center of the collider. We don't want that. We want it from where it's going to be. Offset. Transform.local scale. Wherever the transform is, wherever he's looking, that's that part. Transform forward. It's going to out hit some kind of transform rotation and a maximum distance. That's pretty good. That is pretty good of a thing that we want, right? Some kind of maximum distance. So I like this structure, right? I like this structure. And then the hit, this out hit, out means, remember from your C# class, it's a reference where it's going to store it inside of the raycast hit location, okay? So I like that. M hit detect. Hit detect is a bool or not bool, right? But we don't care about where the player is, right? Do we? We don't care where it hits, or do we? Right? We want to know where the player is exactly. That's going to be the location, right, that we want. So we really don't care about this, but this structure is nice. Local scale and whatever. Let's grab this box cast, and transform local scale is something that we make. Let's see if we can kind of do some of this. So again, I'm just going to put that in there and paste it in, and we'll fix it. So line of sight, instead of collider bound center, we want the transform dot position plus some kind of offset, which is this offset right here. For now, I'm just going to make it so that it is something we calculate every frame, but later on we can assign this plus some kind of offset. That is going to be where it starts. Transform local scale, right, is the scale that we need for the box cast. So that's like half extents. That's what we need. All right. transform.local scale. Okay, we might change this around a little bit. Next, transform forward. That's correct. Okay, hit out, we don't care about. What else can we do though? All right, so what else if we just went comma? What other options are there? Well, we're in this one, right? We just did transform forward, right? Max distance, layer mask, max distance and layer mask. So we want a quaternion orientation, right? And a layer mask. So transform rotation. I want a layer mask and a max distance, right? So layer mask. So a layer mask will tell us what to collide with, right? For example, the player. So we'll say that we'll call this a thing up here that we can access. Public. We'll say layer mask, collision layer is what we want. We'll put that in there. Let's see if that's the right order. Collision layer, right? And modify by the maximum distance, which we said is going to be 10. So I want 10F, right? And that is not the right thing. So it's 10F and then the collision. So layer and then the collision mask. So it's in the wrong order. And then hopefully that will fix it. Yes, it is. That's the way it is. So that's the order that we have to put it in. So it's box cast from the position plus an offset, which we did. Transform local scale is the next piece, which is the extents. Transform forward is where they're looking. Transform rotation is where they're rotating, the direction. 10F is the distance, and collision layer is what they're colliding with. Cool, cool. Let's make this offset something we can modify up there. So I'm going to say that cut. I'm going to put that up here so we can see it. So we can modify the offset later. So let's say public. We'll say collision offset or line of sight offset. That's what it is, right? And it'll equal to a vector 3 object. Vector 3 object that is, which is called line of sight offset, that we're going to set to some value, okay? And this will be for line of sight. So we'll say that header line of sight. Okay, that's what this is. Line of sight, and this will be line of sight offset, just so we can see that in there, so we can not hard code anything. And the same thing goes with this. Instead of offset, we'll get rid of this, and we'll say line of sight offset. Okay, and that's pretty good in terms of the way it's going to work. All right, let's see if what we see works. Okay, now what we also need is when the line of sight is detected. So this is has line of sight. So that's another thing. So we're going to say public a bool, which is has line of sight, has LOS, right? Which is what this is going to be, has LOS. Okay, and that's all it's going to turn on. We're not going to make this a var. We're going to make it so that it is this. Okay, and let's see if every frame we can detect if the enemy has line of sight or not. All right, whew. A little bit of code there, but we're going to be okay. Let's see what happens when I run it now. And we cannot visualize anymore. I think we visualized enough, but let's see what happens. We should see line of sight already. So I'm in front of the, oh, one thing we didn't do, sorry. We didn't choose the collision layer. We want the player layer. We don't have a player layer. Let's add the player to the layer. So we want to make a new layer called player, because we don't want it just to collide with anything. Only the player. There's the player. And then I'm going to take the player, and then I'm going to assign it to that layer. And it says change the children. You know what? I'm going to say yes, and I'm going to fix the thing again. Yes, change the children, and I'm going to go back to the player marker and set it as the marker. and save that. I'm also gonna, there's no player prefab yet. I think it's a great time to make a player prefab just so we don't lose all our settings. So I'm going to go to the prefabs folder and drag and drop the player object in there too. Nice, nice. Excellente. All right, we're good to go. Let's see if now it works. Do we have collision? So it should be, it should say that the crypto should have line of sight at this point, right? Because, right, the player should have line of sight. Let's see if the player has, if he has line of sight anywhere, because that is something that we want him to connect with, right? So it's not quite working. Oh wait, the layer. Let's try that again. Nope. Okay, but let's see if he's got line of sight back here somehow or somewhere else, because we don't want the crypto not to have line of sight. This is the line of sight offset, 0.2 -5, and the line of sight's not really working, right? So collision layer is not really doing it, has line of sight, it's not really working, so it's an issue. And again, this is part of the debugging. We see what we want to do, but, and this is the right way of doing it, guys. All right, this idea of has line of sight offset, and you want to be able to do a box cast of some kind, and transform forward, transform local scale. Might be something we don't want. Maybe what we'll do is we'll do one of these where I say the size is the size of half extents. Let's just use this for now. So just for now, I'm not going to use local scale. I'm just going to use a size, and I'm going to put size in there, see what happens, because that was what worked for us last time, right? Because I think that might be the issue, but let's see, right? And lay. Nope. But let's see if I'm over here. Sorry, I'm just want to make sure that, because we can't see it, right? We only visualize what we can see, and it's not seeing anything. So what is it detecting? It's not detecting anything. Let's see what it's hitting. So it's actually not hitting anything. All right, so let's see everything. So we'll say everything. All right, so not nothing, everything. It should say something. It should say has line of sight now. All right, that's a problem, because even with everything, it's like it literally has nothing that it's colliding with, not even the ground. So that's not working. Otherwise, it would light up, has line of sight, right? So let's take a look at this. Boolean has line of sight, physics box cast. Let's try it again. So I'm just going to try and fill in the blanks again one more time. Has line of sight is equal to physics. You guys can try it at the same time I do. Dot boxcast. We'll try a couple of them. And I wonder if boxcast or boxcast all. Box along array and returns detailed information on what was hit. Center of the box. Okay, center of the box is going to be, like we said before, the offset that we talked about before, which is transform position offset. Okay, I like that. That should have, that's the center of the box. The half extents, cast the box along array and returns half the size of the box in each dimension. Okay, so this is the size. So we're going to say that a new vector 3, actually we'll say size multiplied by 0.5f, because that's half the size of the box in all dimensions. All right, and cool. Size, and then what does it say next? Direction. Transform dot forward. That's that. Transform forward. Cool. And then the next one is quaternion rotation. So whatever the transform dot rotation is, like we said before, and then just checking, right? Maximum distance. So 10f. Okay, let's make it 20f. Really long. And finally, the layer mask, which is the collision mask, collision layer. And I'm okay with that. That should return something. So I did everything right. And let's just use boxcast all instead and see if there's any difference between boxcast and boxcast all, because this is exactly what I put in here. But we'll try it this way first and see if maybe I did something wrong when I did the size times 0.5. Let's see if that made a difference. I don't think so, though. There's something else wrong. Okay, so everything, we'll make it so it's only the player, right? So only the player gets seen. Oh, wait, nothing, only the player. Well, I just want to see if we can see him anywhere else, because we can't, again, can't visualize. So we did that visualization. That's what we want to do, but Boxcast's not really doing what we're expected to do. And let's just make sure that in the scene, again, this is not what's happening, okay? Even though it's showing this, it's not what's happening. Crypto, let's move that up a little bit, and let's take away the Nav Mesh Agent for a second and move this up. And we'll spin them around too, just so that way we can see what he's looking at, if he's looking at anything. Up, and just want to say that if there's any orientation change. Again, I'm trying to get something. It's not colliding with anything. And let's say if I change this layer mask to everything, I just want anything to collide right now. I don't care about what it's colliding with. And let us spin it around this way, and oh, okay. So it looks like it's oriented wrong. Look at that. Because it says everything, and we detected line of sight this way, but nowhere else, right? So this way, and wait, is it this way too? This way, which means, okay, not this way. Okay. So this may be because of the way it got brought in. And what we may have to do is surround this thing by something else, because our orientation might be wrong in terms of the way it works. But that's okay. Now let's do it again. And let's do it by player only. And let's spin it around again. So only player. Well, this is working. Something is working. It's just, I was concerned. I was like, something is wrong. So if I turn it this way now, but only the player, no. And is my player marked? It is marked as player. Yes, yes. But now it's the player, but not everything. So what about if we tried something else? We tried Boxcast All. By the way, there's another one as well we can try. Boxcast All returns a raycast hit, but not a. Let's go back to the Unity documentation. We get this done. And then the draw wire cube is transform position, transform forward, multiplied by hit distance. Okay, and then transform local scale is the wire cube. Transform position plus transform forward, right where you're looking. Okay, let's. I just wanted to try. If there has been a hit, draw the ray at the maximum distance. Okay, so this is what I want. Transform forward times maximum distance times transform local scale. All right, so let's try this instead. Just, I want to, again, I'm trying to visualize, which is the important part. That's why I did it in the first place, because one of the biggest challenges we have when it comes to drawing a wire cube is maximum distance will be the 10. Transform local scale, and we need the offset. So plus offset, plus LS offset, plus transform forward times 10. And we can just get rid of this one and see what that looks like. What does that look like? Local scale. And same. That is exactly what we're seeing. Look at that. So I really haven't changed anything. The offset is correct because we're going from the transform to LOS offset plus transform forward. Okay, maybe this is something that I need to do here. So Boxcast all. So that's Boxcast. The other option is, if this isn't working for us, we can just try Boxcast without a layer mask, so we just care what we hit. Let's just see what we're hitting. So let's try as line of sight. Last things, guys. I know we're working late tonight, but what it is. Physics.boxcast again. But this time we'll just not use the layer mask. So again, we'll do this part. So we don't care about layer mask. And we'll say size is the size. That is half extents multiplied by 0.5f. And then transform forward. And then transform rotation followed by 10.0f. And that should be enough. Orientation, maximum distance. Why is that an issue? Shouldn't be an issue. Because I'm just doing the exact same thing with no collision layer. So it's just colliding with everything. All right, let's see if that works, and then we can detect what we're getting. Because then I can use an out for that detection. All right, so let's see if that works. This looks, and we just want to see it. So it's not detecting anything, colliding with anything. That's with the collider. So if I jump up there, does it move? Does it detect me? I don't care about anything else. I want it to detect me. And it's not seeming to work. Doesn't like that somehow. As line of sight on update boxcast. Okay, let's try something else. Tried rotating. I know it did it though. So friends, what did you put in? Tell me your if you want to put it in there, I'll do it. Layer. Okay. So the first thing I did, right? We're rotating it by so you're talking about this one or this one with collision mask, right? So you're talking about this one, right? Yeah, I don't think so. Without mask. Without mask is this one. But it didn't detect. What is it detecting though? That's the thing. So what we need to do is we need to get that out. So again, going back to this, what they did was they used a hit out, a raycast hit, right? So we can do that too. We can say that we're going to have a raycast hit, which we're going to call hit, right? And let's use that version. So we're going to use, instead of a collision mask, right? So we'll say physics boxcast bounds local scale forward on a hit, transform maximum distance. Okay, let's see, and then we'll get which ones is hitting. Okay, so that's what we'll get more information this way. So again, going back to this, we'll use the hit instead of what we've done so far. All right. Again, this is part of the troubleshooting that we're going through, right? So let's try it again. Physics boxcast. We know the first one didn't work, and this one didn't work. So transform position, line of sight offset, and then size times 0.5. These are all the same, right? Half extents. Then vector 3 direction is transform forward. These are all the same. Now, this is where we get the differences, because if I'm not wrong, after transform forward, then they do the hit. Local scale. So local scale's here, that's the size, transform forward, and then a hit. And then the hit. Transform forward, and then the hit. And then followed by, not hit, just hit. And then followed by the quaternion rotation, which is transform rotation. Transform rotation. All right, so that is that part. Okay, now why is it giving me this? Oh, it's got to be out. Out hit. Right, because it's going to be a reference. So that's almost like it's like putting a pointer in there for C++. Okay, so then what we can do is let's output that. We'll say that debug dot log hit dot object hits dot point dot name dot game object hit dot point dot is it game object or transform hit dot point hit dot what hit dot transform dot game object dot name. There we go. So that'll tell us the name of the game object that it's hitting, if it's hitting anything. All right, so let's see what it does. So back to this. We don't care about collision layer yet, but we'll put it back in there in a second. And okay, it says object reference not set to an instance of an object. What has no instance? Debug log hit transform hit raycast hit. Oh, that's if it doesn't have a hit. So if has line of sight, then and only then tell me what you hit. By the way, there's an easier way I'm going to do it in the next thing. I'm going to do something even easier than this, stupidly, but I'll do it. All right, no line of sight, and you can't see it, but that's okay. And still doesn't detect anything. Where is this looking? Maybe it's looking straight down. You never know. Okay, let's make it so that we'll turn it again, just like we did last time. So here's the player, and let's turn it around and see what it looks like. So, tile 2. Okay. Pillar. So here's where the pillar is relative to this. So put this, let's run this way, this pillar. Okay, tile 2, pillar. So I don't know if you saw what I'm doing, guys, but I'm actually getting an output of what it's hitting, but it's never really seeing the player, right? See that? Which means that the way it's hitting is based on collider. And because my player, this is where the player's collision detection is as well, I don't have a collider on the player, right? I have a character controller, and the character controller has its own collider. This is why it's not working. Let's add a collider. I'm going to add a capsule collider on the player. And I'm going to make it so that the radius is 0.5 and the height is 2, just like before, but we're going to make it a trigger collider. So it's not going to do anything, right? Because if I make it a real collider, it's actually going to trigger something. That's bad, right? So trigger collider on the player. Let's see if that is going to work better for me now. So, yeah, okay. Let's see if what the guy can see. That's the problem. So now, still doesn't see me. That's okay. Let's turn him around and face me. Face me. Does it have to be an actual physical pillar? A little bit offset. Pillar 2, tile 2. And is it a minimum distance? Yeah, so that's what's happening. So it's going away from me by some distance. So that's actually accurate, what's happening. So this is where it's looking. Look at that. It's saying pillar. Is that the pillar? Pillar. Okay, and then is it colliding with the pillar? Okay. So what about if I was further out then? What about if I wasn't here, but if I was like 10, exactly 10? I wonder if it's like exact distance from the player, from the object. Let's see if we do that way. So again, let's move that closer, and we're gonna troubleshoot this like a boss. Okay, let's see how this is. So here, where is it getting us? So it is way over here. Okay. Well, if that's the case, and if that's where it's going, transform forward times 10, well, that makes sense. So what if I said transform position, local offset, and what if we took the local offset away? But that would be messed up, wouldn't it? Because if I just did this, sorry, it's just I would just put it in the ground, right? Yeah, so I was right. So that local offset has to stay on. Transform forward is where it's supposed to be. But instead of the distance away, that's the distance away, and the transform local scale, instead of that, if I did this but half, so size of this divided by half, let's try that. So if I said this size times 0.5, okay, we're getting closer. I'm getting hotter on this one. And then you're going to get a box that looks like this, which is 10 meters away from this. What if I put no meters away? So it's right in front of me. That's what I want. So now let's make it so that the distance, instead of distance being 10, transform rotation, less offset size. So what I want is, I don't want this. Okay. Well, so that distance, that size, right, is okay. It's just that it needs to come back. Let's try it again. All right, so I'm here, and do I have line of sight way out here? No, I don't. And I'm in here? No, I don't. But what about if I'm behind him, where he can get access to me, like way back here? Okay, hold on a second. Now I'll turn him around. I'll turn him around, because he's not actually, it's just over here somehow. And then let's move this guy around. And let's see what I see. Tile 2. Let's move the player back. Yeah. So even so, it's not working. So, but I get it. It's not, first of all, there's two problems. One, it's not detecting me, right? And second, it is the size and distance up. So let's comment this out and uncomment this one. And now let's add that stuff back in with the layer mask. Well, with a transform out. So it goes to transform size, transform forward, and then 10.0. So out hits, and then transform forward, transform dot rotation, and then we can add in a maximum distance and a layer mask of collision layer. Okay, that's going to give us an out, but also going to give us a collision layer. Let's see if that works. I know, guys, I'm running over time, but it is what it is. It's only the player. what if the player had a trigger instead of a capsule collider on the player? What if we made it an actual collider? Wait. Wait, what? On the player, let's make it an actual collider. Shouldn't do anything to us, but let's see if it needs an actual collider or if it's going to mess up. And let's go back to crypto. And behind them, here. We're just going to do this in a second, guys. It's a little different than this. There's another stupid thing we can do. This is how it should work. I'm not sure. I'm having a bit of a brain aneurysm right now for it to work the way it's supposed to work. It's totally supposed to work, by the way. I've done this a million times. So what am I forgetting? It's only the collision player, and I've got the player as collided. Player is a player object. Yeah. Okay, let's just do it all. Go back to that crypto dude. Take that collision layer, everything. Good. And let's keep rotating. Okay. That's frustrating. All right, so because I'm going to get frustrated here before I go crazy. So there's another thing you can do, and this is really dumb, but I've done it before, and what you can do instead of this, all this stuff, is don't even bother with this. I'm still going to have has line of sight. I don't need an offset or a collision layer. No, none of that stuff. Instead, what I'm going to do is I'm going to use a collision detection instead. That's another way to do it. So I'm going to say that line of sight offset, I don't need that. I don't need the wire cube anymore, or even this whole thing. All right, so instead, what we're going to do is make sure we have enough curly braces. We're missing one curly brace. We're going to use on collision, on trigger enter 2D. On trigger, so void, on trigger enter, and we're going to say for is it collision? That's going to tell us on collision and on trigger enter, and it says it has to be a collider. Collider other, and we're going to say that let's just debug log, debug.log, anything that it collides with, other.gameObject.name. Okay, and I am going to do something totally different from this. Instead of this, I'm going to make a new object. This is Capsule Collider that it's going to use to collide, right? And I'm going to add a new component. It's going to be a box collider. And this is another trick that I used in the past, where the box collider is going to be offset. Box collider is going to be offset, let's say by 2.5, and we'll make it wider on this side and on this side. Make it exact. So the center is going to be 0 and 0.5, 0.9, 0.9. That's better. And And the size is going to be on the x-axis. What we're going to say is 4 on the x-axis, and on the y-axis, it's going to be where it is, 2.3. Let's make it 2. And on the z-axis, it's going to be 10. And then we're going to offset it, the 0, 0 mark. The 0, 0 mark is going to be, so this is 5. No, we'll say 10. 10 is good. 10, and then we'll offset this by -5. Offset this by 5. There we go. Okay, so we've done the same thing. This is the extents, like we talked about before. This is his line of sight. And then it's going to go around with crypto, and it's going to be a trigger collider. Now, I do need a rigid body on one of the objects in order for me to do this. So let's see what it does. Does it detect me? Does it detect anything? So it says player. Look at that. So, okay, what if I move over here? So he doesn't have line of sight now, but if I go in front of him, look at this. If I go in front, then he should have line of sight. Okay, cool. So then if that's the case, that works. Let's trigger it. That's real simple. Wow, that's way simpler. I'll say that has line of sight is equal to true, but then we'll also need the other one, which is on trigger exit. On trigger exit. And if the other player, we'll say if other.gameObject.name, if other.gameObject.name is, I will say compare tag, gameObject.compare tag player, as we'll say, then it's true. Otherwise, it won't be true. And if it was true and it leaves, if it was the player but it left, then we'll make it false. So false. Wow. Triggers and colliders. There's something else wrong there, but whatever. I'm making a mistake. But let's see if that works. And then do I see it? Because that's the trigger. Okay, so let's run it. And I should see a crypto. Does it have line of sight? It does. Okay, and what happens when I run it? And let's run away from him. No line of sight. Look at that. So now it works. Let's make sure it doesn't have line of sight someplace weird. Okay, it doesn't have line of sight, but then as soon as I enter this area, it does have line of sight. As soon as I leave this area, it loses line of sight. There we go. Okay, well, that was not what I expected, but okay. Now finally, it worked after fooling around for a bit. I mean, it's something we can visualize. It's like so many things. Anyways, and let's make sure that inside of Crypto's prefab, let's go back. Sorry. Let's go back to Crypto, and we'll also apply all. I'll also take that prefab, Crypto, move this box collider up. And this box collider is really just the detection. That's what we're using it for as a trigger. Wonderful. All right. Oof. Okay, so if I detect the player, then I want to know where the player is indefinitely. So then that's what's going to happen. It's going to happen one time. As soon as I detect the player is going to, my object is going to run towards the player. All right, so let's do that. So player. So let's go back to this. So it's going to say on trigger exit, enter, has line of sight. As soon as I get line of sight, if has line of sight, then what I want is for the agent to set destination to the player location. But we don't know what the player location is until we get it from here. So we'll say player location. So public. We'll also make this part of, say, player locations of vector 3. Vector 3, player location. And we'll say that down in here, when I have line of sight, then other.transform, sorry, player location is equal to other.transform.position. And that is good. And then what I can say is that player location can go there. So it finds the player's location, which means it's going to chase it. And I don't care about it other. This is just, I only want to detect once for now. And then otherwise I can lose line of sight and unset the destination. All right, so then let's see if that works. It should move right towards me. Yeah. So as soon as it detects me, it's going to find, you know, my line of sight, right? And so it's going to find the last place it saw me, right? The last place it saw me, it's going to run towards me. That's what it's going to do. All right, so once I run into its line of sight again, it's going to run into that location, whatever that location was that it detected me. It's going to run there, right? It's going to keep on going as it sees me, right? And what I can do to update the location is I can add in another one of these on trigger stay, which means if I keep having line of sight, and if it's the player, then I'm going to say that I've already got line of sight. Then I want to update the player location again. So this only does it once, but I want to say that this does it all the time. So as I do it, instead of doing it there, this just detects if I have it or not. And actually, no, I need to both places. This will do it once and then again. And let's see if that works. As long as I have a line of sight, this thing will chase me. And if not, so that's good. So let's see, back here. Oh, it's coming at me again. Okay, cool. Now it didn't find me, but it's got my last location, right? And look, it found me again. It's coming at me, and I'm coming on. Okay, cool. Didn't find me again. Here I am. Yeah, and there we go. It's going to find me there again. It's going to come at me. And we can extend the range. I think the range is too long. It's too short. I think it's got to be more than 20. So we're just optimizing now. So instead of my extents being the way they are, we're going to make it so that the Voxel Collider is truly on the z-axis 20, and this will be 10. So way long. So anything like that. So that's reasonable. So anywhere it finds me, it'll see what's happening. And let's see what the heck it does. Okay, so it's kind of coming at me, and it lost track of me. So I'm over here. Okay, good. So it kind of works. So then what I'm going to do is, but it didn't see me. It's like, hey, wait, he's gone. All right, so that's good. That's kind of working interestingly. So what I want to do is, once I have my location, then I'm going to move from idle to run. So this is what's going to happen there. It's going to move from this to this. Else, right? Else if, I will say just else for now, no jumping. And let's just say that otherwise I'm going to go to idle. So idle, and let's leave those the way they are because it's just triggers. And let's see how that works. And then maybe this is going to be okay. Yeah. Until it detects me again. It's going to try and turn to me. Okay, so a couple things we have to tweak. This is going to be the Nav Mesh Agent. We have to stopping distance at 2. And again, you can see how we're just modifying the AI here. Right, so the AI is going to run. And instead of making it so that it turns off, I'm going to say that I want to get the position of the player all the time. So whatever the position of the player is the player object, game object. So instead of player location, we'll get the actual player, the player itself, public game object. So instead of the transform position, we'll get the player. And then I'll find the player when it sees it, player.transform position. And we don't know what the player is, but as soon as it does, if has line of sight, then the player.transform, because the other transform is actually the other .game object. That's what it'll be, and this will be the player. And as soon as I do that, then that's all it needs. It doesn't need this. As soon as it finds me once, it finds me always. That's just the way we'll do it. Make it simple. All right, and let's see if that works. So, and then we'll move this thing around. All right, and let's see if it finds me, if it knows where I am. It does. And how about if I'm over here? Right. So it's finding me now. There. Set destination. Just a moment. So why? Is it because of, sorry guys. Is it because of this thing? Yeah. So as soon as it loses me, I don't have line. Okay. There. All right. So if I don't have line of sight, then I do that, and I find the player once, but then I don't. And it only does the chasing if I have line of sight, otherwise it stays idle. Okay. Yeah, that looks okay. All right, so that's pretty good. All right, so that's the behavior I wanted. Now that we got that, let's get crypto into a prefab. Actually, we have crypto prefab. Let's just save them. Override. Make sure that we have all that saved. Great. And let's move crypto now. So let's move them. And we'll add another one. So move him here. Make sure that he's on the ground or close to the ground, guys, because it's important. Otherwise, he won't work. And let's duplicate him now. We'll put the other one over there on the other side. Let's see. Only the one that's going to detect is going to see it. Yeah, you can do detection radius. Yeah, that's another way to do it. I'm just showing you how to do line of sight, so that way, you know, and it's a cheap way of doing it too, because it's using colliders. Okay, so there it is. So I have two guys. This guy detects me, the other one doesn't. So this guy should move towards me, but this one shouldn't. Let's try this out. He moves towards me. He's moving a little bit slow for his running speed, I find. So that's another thing I got to change. I got to change their movement speed. So right now their movement speed is 3.5. Let's increase that to 5. And let's save that to everyone. Try that. And it's just because of the running. The running looks like he's moving too slow. Okay. He's also, is he pushing me? And then upon arrival, he should just stop. So upon arrival, right, this is another thing you can do. So these are, we don't need these keys anymore. So upon arrival, when I arrive, right, if, and by the way, the agent, so it doesn't matter if I have line of sight, if I'm close enough to the player. So if, well, I guess it would have to have line of sight. So I have to have line of sight, and if agent, sorry, if transform, no, the distance. If vector3 dot distance between the transform dot position and the player dot position, player dot transform dot position, if that is less than 2.5, then animator blah 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 blah. We can, if we had an attack, that would be right here. This could be an attack, so could be an attack. So we can actually do an attack animation right here, because if he's less than 2.5, he's close enough to hit me, right? So there would be a thing that would go there. All right, let's see if that, how that would work, and then let's see how that works. I still think he's a little slow. And then you see how he slowed down. And then if I move, it's not letting me move because okay, bye. Why? Oh. Yeah, so he doesn't see me, but then as soon as he sees me, he's gonna start running after me too, until he's right in front of me and then attacking me. Okay, so I think still it needs to be faster than 5. It needs to be like 6. It's just not, it doesn't match. You have to match the animation with the, you have to match the animation with the speed. And also I recommend an angular speed like of I don't know, something like 180, even faster, because it needs to turn like on a dime. All right, so let's try this again. Okay, and it needs to be a little bit farther away. Stopping distance should be 2.3. Let's try that, because it's going to slow down, right? The acceleration, it's going to accelerate to max, and then it's going to slow down. And then it's like bumped into me, which isn't terrible. Here's the other thing that I want to do. I want him to face me, like we did last time. So when he's near me, so player.transform.position is less than 2.5, he should face me. So maybe we can do a transform. We did this before with the billboarding, right? Oh, we forgot to put that in there too. Transform dot look at, transform dot look at. Again, we want to look at the targets transform, and we have the script for that, actually, the billboard script, which is my health bar world space billboard script, this part, which is kind of what we want to do. Instead of camera.forward, we want the player.forward. The player's camera.forward, whatever the, actually, just the player.forward is fine. So let's see if we can do that. So transform.position plus camera.forward, it's going to be plus player.forward. Player.transform.forward. So in other words, it's going to look at us. It's going to turn to look at us when he's close, because he's looking away from us, and I want him to look at me when he's hitting me. Okay, that is the exact opposite of what I wanted. Transform.position. How about transform.forward? Sorry. Whatever I'm looking at. Nope. How about the transform player.transform? I did a slide. Yeah, that's interesting. Yeah, that's not exactly what I wanted. He runs at me. He's like doing a slide. It's like slides, and it's in the wall. No, it's not what we wanted. Yeah, no, no. I think we had it right when I said the players that transform dot forward, but it's the player camera player dot transform dot forward, and it's like the opposite of that, whatever that is, minus that. So minus, or sorry, it's not the players that transform dot forward. It's players that transform dot back. Yeah, no, there's no back. It's forward. And if I go negative forward, is it going to look at me? Or is it going to look at something else? Nope. Interesting. That's not the effect that I want, okay? He doing all kinds of interesting stuff. Um, hmm. It's kind of the same thing, isn't it? Because we're just doing the same idea. We're saying that the lookup transformed up position plus transform to, so wherever your transformed up position is plus that transformed up position plus. Let's see if we do that or minus. It might be minus. Let's try it. Let me go back to see what it does when I do that. So that's where it's looking. I want to change my position to look at what I'm looking at. So this is what I'm looking at. Okay. So what if I said transform deposition minus what I'm looking at? Is that gonna be okay? So the other way. That's good. Yeah. Yep. That's it. Yeah. Looks pretty good. It's not letting me get away. Okay. All right. And see if this guy is any smarter. Oh, he tried to get me. Oh, but what if he's far away from me now? What if he's not for the first time? All right. If else, okay. So then we'll put this transform deposition. Okay, but we want this to be the else every other time. If he's not next to me, then we'll say that he's going to run every single time. All right. And again, we would put different conditions here because that'll stop him. It'll stop him from running and finding me. So, okay. Let's see if he gets me. He's over here. And I'm going to go over here now and jump away from him, but he knows where I am. And then, oh, there he is again. He's running after me. There I am. He's a robot. All right, and there you go. A simple way of doing stuff. One thing that I would put on them, which is missing, is the enemy marker. No, the enemy marker's there. The health bar. The health bar is the only thing that's missing. So we would put on the health bar world space on top of the on top of him. And of course, what we want to do is, oops, undo. Of course, what we want is this health bar world space to be on top of him, like right there, on top of his head. And then we'll just go crypto overrides apply all. And now we can have a dude that is, well, someone I can kill. And then, what if I go here? He's going to still face me, even though he's not facing me. The health bar will face me, right? See that? and then spacing. Cool. Again, some really weird slidiness on the turning off and turning off the turning on and turning off the thing mechanic, but it's not terribly bad. It's something I can play with and work with, which is what I wanted. Oh, I'm on his head. That's also a problem. Okay, so pretty cool. There you go. All right, so for the lab, we didn't quite get to the particle system, which we use later on. We'll do it next week, not a problem. But for the lab, what I want you guys to do is get this working somewhat like this. It doesn't have to be perfect, right? Where the enemy is chasing him. If you really want to give the player a little bit more space, you can always do additional tiles. We have these tiles here, like this, right? If you want to give them a little bit more space, you can duplicate them and then pull them over. So that way you can have double the amount of space. So there we go. 0. There we go. So we have double the amount of space, and then I can run away from him anywhere I want. So he's going to come at me. And remember, as long as they're in there, if you look at the tile map, so if I look at tiles, then remember that what's happening is that the tiles aren't mapped. One of the biggest problems we have right now is the navigation is only mapped on this side. So what I'd have to do is I'd have to bake it everywhere else, right? And we have, what we can do is on the remaining tiles, which are these ones, I can go to navigation, bake, and click bake, which adds the additional maps and kind of playtime. There are some that didn't get it. Like, for example, this one, for whatever reason, is not wide enough. But this one is wide enough, so it got it. And there are no off mesh links. So if you want them to follow you on the top, then you could make it so that, like we've done before, we could say that I could generate off mesh links again. So let's do that. But let's do it for all of them, not just for some of them. And then later on, next week, we'll talk about a different way of doing this. So bake and bake. Drop height, jump distance. We'll say jump distance will be 2, and a drop height will be 2. Let's say 3. 3. Bake. There we go. Now they'll be able to follow them anywhere. And then save that, and then play, and that will be, he will not be able to escape from anywhere. Over here. Oh, that was weird. I don't like that. He should be running. Oh, this is if I don't have line of sight. That's silly. So he knows where I am, but because I don't have line of sight, then he's doing this. Yeah. Yep. Nope. He should not. That's how it should be now. Sorry. One more change. And then I'll put this up on GitHub. Sorry, guys. I know I'm running a little bit longer than normal. That's normal. I need like 4 hours for this class. Okay. Now you had me, but now too bad. You don't know where I am. Why are you stuck? I'm here. I'm here. Yeah, still got slidey feet, in my opinion. So The other way you can do it is, I mean, I still think he's just way slower than he should be. Like these guys should be like just faster, faster, faster. And I mean, I think even 10 might be fine. Speed 10, acceleration 8, and let's see what that does. It makes it better or worse. Stopping distance 2.3, auto braking. Yeah. Yeah, I think that looks better too. Let's see if this guy sees me. Should. He doesn't see me anymore, so he's going to stop. Yeah, I don't know if I like that. I don't know if I like that at all. So yeah, I mean, it's fine, guys. But what it is only if I have line of sight do I start doing it. Well, what it really should be is if I have line of sight, start running, right? But my agent destination should be set as soon as I have line of sight once. So this should be there. That's correct. But what I should do is, if my vector to distance from my player transform, if I have line of sight, so I'll do it separately. If I have line of sight, and my vector 3 transform, if this is true, then get rid of this. Two, 3 brackets, 4 brackets. 2, 3 brackets. Thank you. Texture radius should make the motion smoother than the line of sight. Yeah, it's going to be different. Texture radius means that anywhere in the radius, he'll turn to find the player. And that's why I said detection radius is an option for you guys, because, you know, you should have both, actually. Line of sight, even if they don't have, not in detection radius, but you can see the player, they should start moving towards the player. And then as soon as they're in detection radius, he'll maintain line, as long as he has line of sight, then as once this has been changed to true, right, then it's going to continue to do it. And what we should do is on trigger exit shouldn't turn it to false. That's also a thing. So once you've had line of sight, you know the player, you've seen him. Once he's been seen, he's been seen. Again, I'm just trying to optimize here, right? So that way it's always, once you detect the player, he's detected, and then he's going to come after him. Let's see if that's a little bit better. So he's never going to stop running after the player. Once he sees him, he's always going to see him. Right? Always going to see him. Once you see him, he's always going to see him. There we go. That's how it should be. This guy's a little bit stuck, but only because there's no off-mesh links for that one. And then he's going to try and get, there we go. That's better. And they're going to push me off. And this guy's too far. That's why he's not stopping. Better. I like it more. Okay. Again, you can see how that works, how it triggers so what we covered today was really animation and a little bit of how to use animation with an AI. Is it perfect? No, it needs more work. And as you can see, it's something that we can continue to work on to improve. But now these guys have everything that you need them to have, right? And just make sure that everything is good. Yeah. Everything is good on this one. Everything is good on that one. Yeah. I'm going to save this, save project. And that should give you a lot to go with your enemy AI, right? With animations. Again, you can make this very simple. I made it more complex because I wanted to play with. I also didn't use the jump. For example, when they're jumping across, if they ever get on top of this, which I didn't, somehow it's not letting me get on top. Then when they jump, we could trigger a jump. When they're on an off-mesh link, you can detect that with the agent. For example, if I'm on an off-mesh link, right, So I have line of sight. It's true, and I'm on an off, on a off mesh link, right? So if it says agent, and then if I said off mesh link is on off mesh link, if I'm on there, then I can do the jump. So I'm jumping from one place to the other. If I'm jumping up or jumping down, then I can instigate the jump. I can say that if this is true, so this is going to be a thing. If I'm on an off mesh link, this is going to be weird. Then I can animator set trigger blah blah blah, which is going to be on jump, right? And that would be weird, right? But let's see how that works. One more thing before we go, because you can kind of make it so that if they're on a jump off mesh link, then cool, they can do it, kind of thing. He's going to try and keep running at me because he's got no way of getting to me. He might be a little bit too wide. And what if I put him on the link, like on the top? Will he be able to jump down? Let's see if we can do that with this guy. So one last thing, sorry. So let's put one of them, let's put this guy on the link and see what happens when he jumps down. Does he do the jump? So do this guy and he'll be here. Yeah. Close enough. All right, so let's see what happens when he's there. So he's there and he's coming at me and I run and I jump. I'm there and now let's, oh, hey, that's pretty good. Okay, but now he is stuck. Yeah. Yeah, these are pretty narrow. So maybe it's because he's just they need to be even narrower than this. Okay. That's enough playing around. Again, you can do a lot more work in here and slow it down. And then when they're close, they do an attack. Like very simple things. And for an attack animation, just like we said last time, last thing I'll do today, I'll show you where it is. Remember that Mixamo has a bunch of things you can look for an attack. Some kind of combat, right? There we go. Look, there's a zombie attack. Let's do a punch, right? Like, or some kind of zombie punching, a punch, right? You can see that. And so they can do that punch. And that'll be another animation where they kind of hit you or they slap you, right? Let's see if there's a slap, some kind of slap. Rust, slash. No, that's a clap, not a slap. Hell slammer, there we go. So we can do a hell slammer. Bam, bam. There we go. Oh, he's gonna do like an actual move. Yeah, so something like a hit or a punch or something like that, where he's doing not a cheering, maybe some kind of hit, maybe a kick. How about a kick? Even better. So drop kick. See that one? Bam. MMA kick. Bam. Yeah, that's it. These guys kick. All right, and then that's what they'll do. You put that kick in there as an example, and so that's what he'll look like. He'll come close to you, and then when he's close enough to you, he'll just kick you in the head. And you have to time it. You have to also look and see what that looks like and stuff. But you can do a lot of really cool things, right? And that's the idea. All right, guys, that's it for me today. I know we went way over again. Hopefully that helped you with the idea, how it works. And I think that's what I'm trying to do here, teach you ideas and try and get you guys to get through. Chadwick says, if it's fine, we did the animations for the project with anim files without having them inside a scanned FBX, as long as the animation transition works. Yeah, I'm good. I'm showing you, Chadwick, I'm showing you if just in case you didn't have, like for people who are non-gaming students or who didn't investigate that, I wanted to give you guys options. That's what it was, right? So All right, that's it, guys. We went way over time. Thank you so much for watching this one. And I'll put the video up on eCentennial. And good luck with everything. Take care. And I'll see you guys on Friday for people who I'm going to answer questions to for Friday. Okay, good luck on the lab. Again, you know what to kind of get. It's really, what you really want to do is you want to grab the agents. You want to show them that they move and a couple screenshots, and we're good to go. All right, that's it for me, guys. Thank you so much. I'll put everything up on GitHub in a sec.